Hello there, and welcome to Life Beyond Seen, where curiosity slows its breathing a little, science settles into a quieter voice, and the world becomes easier to look at when the day is nearly done. Tonight, we are drifting towards something so familiar that it can seem ordinary, and yet so large that the mind has trouble holding it still for more than a moment. We're talking about the ocean, not just the water you see from a beach, or the waves that arrive and leave with that steady confidence only waves seem to have, but the whole thing, the true size of it, the reach of it, the fact that one word, ocean, somehow has to carry a reality that wraps around the planet, shapes the weather, hides mountain ranges, carries life from coast to coast, and still manages to look almost casual while doing it. It is one of those things people use small words for, which is a bit suspicious really. Sky, time, sea, tiny names for enormous subjects. You can stand at the shore in sandals, holding a drink in a paper cup, and look out at a body of water large enough to make your daily worries feel badly organised. The ocean has that effect. It does not shout. It does not perform. It simply extends. It keeps going after the eye gives up. It goes on past boats, past weather, past shipping lanes, past the last place where sunlight feels friendly, and then farther still into regions so cold, dark and pressurized that they sound less like destinations and more like administrative warnings. And yet most of us meet the ocean in very small ways. We see a strip of it during a holiday. We catch a glimpse from an airplane window. We walk a pier and say, "That's lovely," in the same tone we might use for a well-made soup. We put it on postcards. We frame it in photos. We talk about going to the sea as if it were a modest outing rather than an encounter with one of the largest connected systems on Earth. There is something very human in that. Faced with something too large to absorb all at once, we shrink it into manageable pieces. We give it a beach towel, a horizon line, a seafood menu, and a weather report. It helps us function. Still, the real ocean does not become smaller because we have made it convenient. It remains what it is, vast beyond instinct, difficult to picture, hard to compare honestly with anything in everyday life. A city can be large, a country can be large, a desert can be large, but the ocean plays a different game. It spreads in 3 dimensions. It is wide, yes, but also deep in ways that are not easy to imagine unless you enjoy picturing entire mountains hidden beneath water, which, to be fair, some of us do. It reaches into climates, coastlines, migration patterns, storms, oxygen cycles, food webs, trade routes, and the history of nearly every civilization that ever looked at a shoreline and wondered whether getting in a boat was bravery, ambition, or an administrative error. So tonight, we're not going to hurry past it. We are not going to treat the ocean like a blue patch on a classroom globe and move on. We're going to stay with the size of it and let that question unfold properly. How big is the ocean really? Bigger than a beach day, certainly. Bigger than a map can make it feel. Bigger than the horizon suggests. Bigger than most numbers sound when you first hear them. The kind of big that starts as geography and slowly turns into perspective. And before we drift any farther into it, let me gently ask you something. Where are you listening from tonight? Are you near water, where the air carries that faint salt smell, and windows gather a little mist? Are you inland, far from any coast, hearing the word ocean as something distant and slightly mythic, like a place that belongs equally to holidays, documentaries, and old stories of ships getting into trouble? Is it late where you are? Is the room dim and quiet? Are you listening from bed, from a sofa, from a train seat, from the side of a long day that has finally started to loosen its grip? However and wherever you are arriving here, I am glad you made it. And if this quiet journey turns out to be a pleasant place to rest your thoughts for a while, if you find it calming, interesting, or simply a decent way to let the day step aside, I would be very grateful if you like the video and maybe subscribe to the channel. It helps this small corner of slow curiosity reach more people who might also want a gentler kind of company at the end of the day. There are worse uses for the internet than helping someone fall asleep while thinking about continental shelves. Now, I should say, there is always a small risk with subjects like this. Sometimes the world gets more interesting the more closely you look at it, and then instead of becoming sleepy, you find yourself lying there at midnight thinking about underwater mountain chains and whether the Pacific Ocean is being unreasonable on purpose. If that happens, I can only apologise lightly and point out that at least your insomnia has picked a respectable topic. The strange thing about the ocean is that it feels understandable right up until you try to measure it honestly. Up close, it seems simple enough. Water, waves, foam, tides, gulls with questionable manners, perhaps a child building a sandcastle with the intense seriousness of a civil engineer. It feels local, personal even. You can dip a foot into it. You can hear it from a hotel room. You can sit beside it with your shoes off and decide for a few minutes that all important decisions should be postponed until tomorrow. The surface experience is intimate, manageable. You know where you are with it. Then you begin asking larger questions and the ground starts slipping away. How much of Earth does it cover? How deep is it, really? How much water is in it? How far apart are one side of the ocean and the other? What lies beneath the part ships cross without thinking much about what is under them? How much of it have we actually explored? And perhaps most unsettling of all, how is it possible that something covering most of the visible planet can still remain, in major ways, unknown? That is when the ocean changes shape in the mind. It stops being scenery and starts becoming scale. A shoreline is a very persuasive liar in that sense. It gives you an edge, and edges make things feel containable. You see where the water begins, you see where land ends. The brain enjoys this arrangement. It likes boundaries. It likes a nice clear line. But the shore is only the meeting point, not the measure. Standing at a coast and deciding you understand the ocean is a bit like standing in a doorway and deciding you understand the whole house. You have encountered an entrance, not the total. Maps do something similar. They help, of course. We would be in a difficult administrative situation without them. But maps also flatten what should make us pause. Blue spreads across the page, and because the page is calm and still and foldable, the ocean seems calm and still and foldable too. A printed atlas can put the Atlantic next to your elbow. A school globe can let a child spin the Pacific with one finger. That is useful, but it is also misleading in the subtle way all successful representations are misleading. The ocean on a map is reduced to colour and outline. The real ocean has weight, volume, pressure, movement, darkness, temperature layers, trenches, currents, storms, living systems and distances that take days to cross even in machines specifically designed for crossing them. It also has a curious habit of defeating our usual language for size. When we say something is big, we often mean it is large compared with us. A building is big because it towers over a person. A mountain is big because it dominates a valley. A city is big because it holds millions of lives at once. But the ocean does not merely exceed us. It exceeds the scale at which ordinary comparison remains comfortable. You do not compare yourself to the ocean in the same way you compare yourself to a building. The relationship is too uneven. A building is made by creatures your size. The ocean is not. It belongs to planetary processes. It does not care about your proportion. It simply occupies its place in the structure of Earth with quiet, overwhelming authority. That may be one reason people often speak about the sea in emotional terms before they speak about it in scientific ones. They say it feels endless. They say it is calming, or frightening, or humbling. They say it makes them feel small. All of that is true in a practical sense, because our emotional response is often the first honest measurement tool we have when our numerical instincts fail us. Before you know the figures, you know the sensation. You know that standing by a large body of water changes the way your thoughts arrange themselves. Some people find relief in that. Others find a mild and perfectly reasonable discomfort. The ocean can be soothing and unnerving at the same time. It offers beauty on the surface and then quietly reminds you that the surface is not the whole story. There is also the matter of visibility. Much of what makes the ocean large is hidden from normal experience. On land, scale announces itself. You see the mountain, you see the canyon, you see the plains stretching away. At sea, the largest fact is often invisibility. You look outward and see surface. You look downward and, after a certain point, you see less and less until vision is no longer much use at all. That hidden depth matters. It is part of why the ocean can remain mentally underestimated. Our brains are very responsive to what they can see all at once. The ocean withholds most of its bulk from casual inspection. It is modest in presentation and excessive in reality. Even the horizon contributes to the misunderstanding. That neat line where the sea appears to end is one of the most convincing illusions in ordinary life. It feels final. It feels like an answer. Yet the horizon is simply a limit of your position, not a limit of the water. It moves with you. Walk forward, sail forward, fly forward, and it slides away without apology. The ocean does this often. It allows you to feel briefly oriented and then reveals that the orientation belonged more to your own perspective than to the thing itself. This is part of what makes the question so satisfying to sit with. How big is the ocean really? It sounds simple, almost childlike, the kind of thing someone might ask while staring at waves with shoes in hand. But the answer is layered. There is the size we feel. There is the size we see. There is the size maps suggest. Then there is the size science measures, and that last one is usually where the breath catches a little. Because once you move from shorelines and impressions into percentages, depths, volumes, distances, and seafloor geography, the ocean stops behaving like a backdrop and starts looking more like one of the main structural facts of life on Earth. And yet, for all that scale, people have always tried to bring it closer. Sailors named its parts. Coastal towns built routines around it. Fishermen learned its moods well enough to work beside it. Explorers crossed it with courage and poor forecasting. Scientists dropped instruments into it, sent vessels over it, lowered machines into it, and built careers around understanding a fraction more of what lies below. Artists painted it. Poets, predictably, wrote too much about it. Children ran into it fully convinced they could conquer it with a plastic bucket. Humanity has spent a very long time making personal contact with something that remains, on a planetary level, far larger than personal contact can explain. There is something comforting in that mismatch. Not everything has to fit neatly inside our habits of understanding. Some things can remain larger than us without becoming hostile. The ocean is not a puzzle waiting politely for one final piece. It is an active, moving, changing reality that supports life, shapes weather, stores heat, carries memory in layers of water and sediment, and still leaves room for surprise. Even now, in a world very proud of satellites, sensors, and high-resolution everything, the sea keeps some of its distance. It lets us measure more and more, certainly, but it does not become tame just because our instruments improved. So as we ease into this question together, it helps to leave behind the smallest versions of it. This is not just, how wide is the beach? It is not, how far is it to the horizon? It is not even, how much water is there? Though we will absolutely get to that. Because once people begin counting an entire ocean, human beings become very hard to stop. What we're really asking is how large the ocean is in every sense that matters to a curious mind. In area, in depth, in volume, in influence, in the strange gap between what we can picture and what is actually there. That gap matters more than it first appears. It is where wonder usually begins. Not wonder in the dramatic sense, not fireworks and orchestras and everyone gasping on cue, but the quieter version. The kind that settles in when a familiar thing becomes unfamiliar in the right way. The kind that makes you realise you've been living beside a fact all your life without fully noticing its size. The ocean has that quality. Many of us have looked at it, Fewer of us have really paused over what we are looking at. And once you do pause, once you stop treating the sea as scenery and start treating it as scale, the next step comes almost naturally. You begin to notice that even before we get to the hard numbers, the ocean already does something unusual to the mind. It feels larger than the map, larger than the shoreline, larger than the horizon, larger than the little blue shape we're taught to recognise on globes. It has a way of overflowing the containers we use to think about it, which is why the best place to go next is not straight to a statistic, but to that first simple mismatch between the ocean as we usually picture it and the ocean as it actually is. One of the strangest things about the ocean is that we all know it is large, and yet most of us still underestimate it almost every time we picture it. That is not because we are bad at geography, or because school maps failed us completely, though some of them certainly tried their best with limited paper and a very optimistic use of blue. It is because the human mind is not especially well built for imagining scale once that scale becomes too wide, too deep, too continuous, and too lacking in ordinary landmarks. The ocean does not fit neatly into our everyday habits of seeing, so when we try to hold it in the mind, we quietly shrink it. A map is part of the problem. A useful problem, but a problem all the same. Maps are wonderful little acts of compression. They take something too large to carry and turn it into something you can fold, scroll, pin to a classroom wall, or glance at while pretending you definitely know where your ferry is going. That is a remarkable achievement. But every map is also a compromise. It has to flatten a curved planet. It has to reduce distance into symbols. It has to represent depth with colour, motion with stillness, and the size of entire basins with a patch of blue no larger than your hand. The result is helpful, but it is also misleading in quiet ways. Land helps a map feel real, because land is full of shapes we recognise. Countries have outlines. Mountains can be marked. Cities can be labelled. Rivers can be traced like branching threads. There are edges, borders, roads, names, and small visual interruptions that give the mind something to grab onto. The ocean, by contrast, often appears on a map as a broad blue space between the important bits, which is a little unfair considering it covers most of the visible Earth. It gets represented as background, and backgrounds rarely get the respect reserved for things with labels and political disagreements. This has consequences for how we imagine size. The brain likes detail because detail creates scale. A crowded city map feels dense and significant because it is full of lines, names, blocks and structure. A blue expanse with only a few scattered island dots looks simpler, and simplicity often tricks us into reading something as smaller or less substantial than it really is. If a child sees a map with Europe crammed full of countries, roads and place names, and then sees the Pacific Ocean occupying a large but mostly empty stretch of blue, there is a good chance the ocean will feel like the easier thing to dismiss. It looks visually calm, it looks like spare space, it is anything but. Then there is the matter of projection, which sounds like a small technical detail until it starts quietly rearranging the planet. The Earth is round, maps are flat. Those two facts do not cooperate especially well. To get a globe onto a rectangle, something has to give. Shapes stretch, areas distort, distances become less intuitive than they appear. Some of the most familiar world maps make places near the poles look larger than they really are, while areas closer to the equator are handled differently. This can confuse the eye in all kinds of ways. The ocean is not immune to this. Depending on the map, it may look wider, narrower, or oddly balanced against landmasses that seem more dominant than they truly are. So even before we begin to think seriously about the sea, the image we start from has already introduced a few polite lies. But even a perfectly designed map would struggle to communicate what the ocean feels like in terms the body can understand. Human beings are terrestrial creatures. We evolved among trees, rocks, weather, and terrain that can be crossed on foot, or at least looked at with some hope of eventually getting around it. Land teaches you distance in manageable chunks. A hill can be climbed, a road can be followed. A valley can be crossed if you have enough snacks and pour enough judgment. The ocean does not offer that kind of relationship. You cannot stroll across the Atlantic to get a better sense of its proportions. You cannot stand in one place and see the middle of the Pacific just to settle yourself. The sea exceeds our natural methods of measuring. That is part of why coastlines are so deceptive. A coast introduces the ocean in a way the mind can tolerate. There is sand, or rock, or a harbour wall. There are waves arriving in regular lines. The water meets the land, and that meeting gives the whole thing an edge. Edges are comforting. They suggest that whatever lies beyond them has some kind of shape we can eventually understand. You can stand on a beach and feel that you're looking at the sea. In one sense you are. In another you're looking at almost nothing of it at all. What you're really seeing from shore is surface, and only a very small portion of surface at that. The horizon looks like a limit, but it is only the boundary of your view. At sea level, the horizon is not especially far away. It is just far enough to feel meaningful. That is what makes it persuasive. It gives the eye a clean stopping point. Water appears to end there, sky begins above it, and the brain forms a tidy picture. Yet the actual ocean continues well beyond that line, and then beyond the next line, and the next. The horizon is not the ocean's edge. It is your own. This is a very human mistake, and not just with oceans. We often confuse the boundary of our perception with the boundary of the thing itself. If something disappears from sight, it begins to feel complete in the mind. Mountains hide behind ridges. Roads vanish over hills. Forests stop where the trees become too dense to see through. The ocean uses this tendency brilliantly. It presents a calm, visible surface and then removes almost everything else from view. Its greatest scales are hidden by curvature, darkness, and depth. You get a thin sample and call it a whole. It also does not help that many of the usual clues we rely on for judging size are missing at sea. On land, you estimate distance by comparison. A tree next to a house, a person next to a car, a building next to a street. Even if you are not doing the math consciously, your brain is. It is constantly using known objects to make sense of unknown space. Out on the open water, many of those cues disappear. There may be no trees, no buildings, no roads, no fences, no familiar structures shrinking into the distance. Just water, sky, and perhaps a boat that looks small enough to be decorative, until you realise it's a full-size ship carrying enough cargo to make your weekly shopping seem deeply unserious. Without reference points, the brain struggles. Vast spaces can look oddly small or strangely close when they lack objects to compare them against. Pilots, sailors, and explorers have known this in practical ways for a long time. Open water can distort your sense of position, distance, and motion. The same sea that feels endless from one angle can look almost toy-like on a chart or from high altitude. It is not that the ocean changes, it is that our methods of reading it are inconsistent. And then there is the issue of depth, which maps are particularly poor at making intuitive. We all know the ocean has depth. This is not news. Even a child dropping a pebble off a pier understands that water goes down as well as out. But knowing that in a casual sense is very different from feeling the true vertical scale of the sea. On a surface map, depth is often shown by shades of blue, contour lines, or labels most people glance at once and then forget. Darker blue means deeper water. Sensible enough. But colour alone does not force the imagination to behave honestly. A trench marked on a map may look like a decorative groove. In reality, it can be a colossal cut into the planet, deeper than many people ever fully picture. This matters because size in the ocean is three-dimensional. A desert may be broad, a forest may be broad, a plain may be broad, but the ocean combines breadth with depth on a scale that makes comparison difficult. A map mostly gives you area. The ocean's reality includes volume, and volume is harder for the mind to keep hold of. We are not especially good at visualizing how much space is contained in something when much of that space is hidden below a surface. A lake can already trick us this way. The ocean does it on a planetary scale. There is another quiet reason the sea feels bigger than the map, and it has to do with time rather than distance. Oceans are not just large places. They are slow-moving systems with processes that take place over enormous stretches of time and space. Currents travel across basins. Water masses move and mix. Storms gather strength over warm surfaces. Waves generated far away arrive at shores that have never seen the winds that made them. On a map, these movements are often reduced to arrows, if they're shown at all. But a current crossing an ocean is not really an arrow. It is a moving body of water with structure, temperature, speed, and consequence. It is a route followed by heat, nutrients, drifting life, and weather influence. The map gives you the line. The ocean contains the event. That difference between symbol and reality comes up again and again. Shipping routes look tidy on charts. In life, they cross waters capable of changing suddenly and badly. Island chains appear as little dots. In reality, they can be separated by distances so large that hopping casually between them would require either an aircraft or a very strong commitment to becoming a historical cautionary tale. Even continents themselves can seem oddly near each other on certain world maps, because the oceans between them are flattened into shapes the eye reads too quickly. The Atlantic often suffers from this. On a map, Europe and North America can seem almost conversationally close, as if a determined person might manage the crossing after lunch. In real terms, it is an enormous body of water with weather, depth, and scale enough to humble that thought immediately. The Pacific is perhaps the greatest offender when it comes to being underestimated on maps, mainly because it is so wide that many common map layouts cut it at the edges. A world map often places the Atlantic in the centre and splits the Pacific in two, one half on the left edge and the other on the right. This is a reasonable design choice if you enjoy fitting the planet onto paper, but psychologically it breaks the ocean into pieces. A single immense connected basin gets presented as two margins. The eye sees edges, not continuity. The mind thinks, there is some water over here and some more over there, rather than, this is one enormous oceanic space so large that our map had to slice it apart to make the page behave. That is a powerful distortion. What is broken visually tends to feel smaller than what is kept whole. It is like showing someone a very large room by giving them two separate door views and never stepping back far enough for the room to reveal its full size. The Pacific especially suffers from this because its sheer width resists easy presentation. When seen centered on a globe, it suddenly feels much more honest. Not friendly exactly, but honest. You start to notice how much of the planet is water before you reach anything resembling a major landmass. It is less like crossing a gap and more like committing to an environment. Experience changes all of this. People who cross oceans by ship or spend extended time at sea tend to describe the scale differently than people who know the ocean, mainly through coasts or maps. Once you live with the sea day after day, once the land disappears and remains absent, once the weather becomes the main feature of your surroundings and the horizon repeats itself in every direction, the mind begins to adjust. The ocean stops feeling like a border and starts feeling like a world. That shift is important. From land, we often think of the sea as what lies between places. From within it, the ocean is the place, and the land becomes the interruption. There is something almost comical about how stubborn the mind can be until that shift happens. We can know intellectually that oceans cover most of the planet, and still hold a mental picture in which the continents feel central, and the water feels secondary. The sea is treated as the empty bit between the real destinations, which says more about the habits of land mammals than it does about Earth. Seen honestly, the opposite case is not unreasonable. Much of the planet is ocean. Land is what breaks the surface. That perspective takes a moment to settle, but once it does, maps begin to look different. Blue is no longer background. It is structure. It is not blank space. It is the dominant physical environment of the planet's surface. The continents begin to look less like the main content of Earth, and more like islands in a much larger watery system. Even the phrase, the world map, starts to feel slightly biased, as if we had been drawing the house by focusing mostly on the furniture. And yet the map is not the villain here. It is just limited. It does what it can. It gives us outlines, names, routes, and a way to orient ourselves. That matters. But to understand why the ocean feels bigger than the map, you have to notice the difference between a representation and a reality. The representation is flat, visible all at once, and built for quick comprehension. The reality is curved, deep, moving, partly invisible, and far too large to be understood in one glance. The first fits on paper, the second shapes the climate of the planet. This is also why photographs from space can feel more revealing than maps, even when they contain less explicit information. A view of Earth from orbit often gives the sea back some of its proper authority. The blue is no longer just a fill colour, it is the dominant visible fact. Clouds swirl over it, continents interrupt it. The scale relationship becomes harder to ignore. Even then, the image is still just a surface view. It does not show the trenches, the slopes, the abyssal plains, the submerged mountain chains, or the sheer vertical volume of water below what appears so smooth from above. But it helps. It reminds us that the ocean is not a gap. It is a main body. Once that idea settles in, another one follows naturally. The map can hint at size, and the globe can improve the hint. But neither quite tells you what the ocean is like at the level a human being can actually sense from a shoreline, because there is a second layer to this illusion. Even after correcting for maps, projections, and all the tricks of representation, the sea still behaves strangely when you meet it in person. It can feel both close and unreachable, bounded and endless, simple and impossible to grasp. And a great deal of that begins right where the land gives way to water, at the shore, with the horizon sitting there calmly as if it has explained anything at all. There is a very particular kind of misunderstanding that happens at the coast. It is not foolish, and it is not rare. In fact, it is probably the most natural mistake a human being can make when standing beside the sea. You arrive at the shoreline, look out across the water, and your mind quietly decides that this is the ocean. Not a sample of it, not an edge condition, not the smallest polite introduction the planet could offer before the real scale begins, but the thing itself. It feels complete. You have the sand beneath you, the wind moving over the surface, the waves arriving in dependable lines, and that long, clear boundary where the sea seems to meet the sky. It feels like enough to understand what is in front of you. And in one sense, it is enough. It is enough to feel the temperature in the air change, enough to hear the sea before you see it, enough to notice that your thoughts become slightly less urgent when the horizon is doing most of the visual work, enough to understand that the ocean is large, active, and not especially interested in your timetable. But it is not enough to grasp scale properly, because the shoreline gives you the ocean in the most manageable form possible. It introduces the sea in pieces the body can tolerate, a strip of beach, a band of water, a horizon line, a few nearby waves with names like breakers and foam that make the whole arrangement sound almost domestic. The human body loves this arrangement because it is built for local experience. We know how to read near things. We are very good at surfaces, edges, textures, and immediate distances. We know how far away a person is. We can estimate the size of a dog, a chair, a doorway, a parked boat, a lighthouse, a gull behaving like it owns the place. Our senses evolved for this range. They were not designed to interpret the true size of a planetary ocean from a standing position next to a snack bar and a row of windbreakers. So the mind does what it always does when reality exceeds its comfortable range. It simplifies. That simplification begins with the shoreline itself. A shoreline is an edge, and edges are psychologically powerful. They make things feel contained. The moment the sea meets land, the mind gains a reference point, and with a reference point comes the comforting illusion that the rest of the scene may be understood from there. This is why a beach feels so different from open water. On a beach, one side of the world is fixed. You can turn around and see land, buildings, dunes, cliffs, roads, people. Perhaps a cafe selling chips at prices that suggest potatoes have become a luxury commodity. You're anchored. The land tells your nervous system that the scene has order. The ocean benefits from that order without deserving the credit. It borrows containment from the coast. It appears bounded because one side of your experience is bounded. If you removed the beach and placed yourself in a small vessel far from land, the whole emotional geometry of the sea would change. What felt picturesque from shore would become enormous. What seemed like scenery would become environment. What sounded restful in a hotel brochure would begin to sound like weather reports and practical concerns about fuel, navigation, and whether the horizon has always looked that identical in every direction, or whether that is a new way of becoming slightly uncomfortable. At the shore, though, the sea remains legible. You can judge the height of a nearby wave because it rises next to a person or a pier. You can judge the width of a cove because cliffs contain it. You can judge the distance to a buoy because you know roughly how large buoys are, even if you have never had any reason in life to think very hard about buoys before. All of these local clues create a sense of competence. The coast feels readable. But the moment you try to extend that local reading outward, the scale breaks down. The main reason is the horizon, which is one of the most elegant visual tricks in ordinary life. It looks like a destination. It looks like the edge of the visible sea. It feels like a useful answer to the question of how far the ocean goes. But the horizon is not a feature of the ocean in the way a reef or a bay is a feature. It is a feature of your position on a curved planet. It is not telling you where the sea ends. It is telling you where your sight gives out. That difference matters. It matters because the horizon feels so final. It is a clean line. The sky sits above it. The sea sits below it. It has authority. You can point to it. You can watch the sun sink toward it and feel, quite reasonably, that the world has become very dramatic for your benefit. Yet if you walk along the shore, or climb a cliff, or board a ship, the horizon shifts. It recedes. It moves farther away because it was never the ocean's boundary at all. It was always your own. At sea level, the horizon is not terribly far away. That is one of the facts that surprises people when they first hear it in precise terms. Because the view feels grand, we assume the visible distance must also be immense. But the visual drama is not the same thing as the measured reach. The world looks vast at the beach because it is open, not because your eyes have suddenly acquired planetary privileges. Even on a clear day, what you directly see from the shore is only a very small fraction of the ocean's surface. The sea feels endless because it withholds most of itself so effectively. This withholding creates an interesting tension in our perception. The ocean looks simple at a distance and complicated up close. Out on the horizon, it is just a band of colour and light. Nearby, it is full of texture. Ripples, swells, broken foam, darker patches, reflected sky, moving tides, weed, spray, shifting sandbars, water curling over itself in endless small reorganizations. The close range tells you the sea is active. The long range tells you it is smooth. Put those together and the mind receives two conflicting messages at once. The ocean seems detailed and featureless, near and unreachable, intimate and vast. That conflict is part of why the sea is so difficult to size with instinct alone. A person standing on a beach can sense width more easily than depth. Width at least offers a visible plane. The water spreads left and right across the coast. It moves away from your feet. It claims the middle distance, but depth is almost entirely hidden, and because it is hidden, it barely enters ordinary perception at all. You may know that the water becomes deeper farther out, but that knowledge remains abstract unless you have dived, sailed, or spent time learning what lies beneath the surface. The body at the beach mostly reads the sea as a face, not a volume. This is one of the most important limits in the size we can actually sense. human perception is heavily biased towards surfaces. We see the top of things and build our understanding from there. A field looks flat until you walk it. A forest looks two-dimensional until you enter it. The ocean magnifies this habit because its surface is all most people ever encounter directly. It can be calm, rough, glittering, grey, cold, inviting, or hostile. But whatever mood it takes on, it still presents itself first as surface. The great bulk beneath remains absent from normal experience, and absent things are easy to underestimate. Even sound contributes to this half-understanding. The sea sounds large. It absolutely does. That constant movement, the repeated collapse and retreat of waves, the deep rumble under stronger surf, the hiss of foam sliding over shingle, the irregular thump against harbour walls or rocks, all of it tells the ear that the thing in front of you is not small. But sound is a strange guide to size. It communicates force more readily than scale. A stormy shoreline sounds bigger than a calm one, even though the ocean behind both remains the same body of water. The ear notices intensity, rhythm, and nearness. It does not tell you how much sea exists beyond the sound. Smell works in a similar way. Salt air, seaweed, wet sand, the faint mineral scent near tidal flats, the sharper tang near harbours or rocky coasts. These are powerful signals of place. They can make the sea feel close before it comes into view. But again, closeness is not size. The ocean is very good at announcing itself locally. It is much less cooperative when asked to reveal the true extent of its body. There is also the matter of movement, which our senses often misread. From the shore, the sea appears to come toward us. Waves approach, break, and withdraw. The entire visual pattern is one of arrival and retreat. It feels cyclical, bounded, almost conversational. The ocean seems to be doing something with the land, engaging it directly, exchanging energy at the edge. And this edge behaviour is real, of course. Coasts are active zones. But because the sea's visible movement is concentrated at the shoreline, the mind can begin to treat the whole ocean as if it were fundamentally a coastal phenomenon. Waves on a beach become the sea in miniature, and the miniature quietly stands in for the whole. That substitution is misleading. Much of the ocean does not look or behave like a beach. Open water far offshore can be structured by long swells, currents, winds, and weather systems that are not well represented by the familiar crash and foam of the coast. Tides rise and fall differently in different places. Surface conditions vary enormously. Whole regions of ocean can look placid, while concealing immense depth and distance below. But the shoreline is what most people know, so shoreline logic tends to dominate their imagination. The horizon encourages another common misunderstanding, which is the idea that the ocean's size is mainly horizontal. We naturally think of it as something that stretches away from us. Breadth is obvious, depth is not. Yet the ocean is not just a spread of water across the Earth's surface. It is a three-dimensional mass. From the shore, however, vertical scale is almost impossible to sense honestly. The water at your feet may be shallow. The line farther out may suggest gradual increase. But nowhere in the visible scene does the true depth announce itself. There is no sign over the water stating that beneath this neat silver strip lies an underwater landscape of slopes, plains, trenches, ridges, and darkness beyond ordinary experience. The coast gives no direct visual warning about how far down the world may go once the shelf falls away. Cliffs help a little. From a high headland, the sea can feel larger because the visible surface expands. The horizon moves farther out. Ships reveal themselves more clearly. Curvature becomes easier to suspect, if not consciously notice. The sea gains breadth in the eye, but even there, the gain is modest compared with the reality. Height improves the view. It does not solve the scale problem. It simply gives the body a slightly larger slice of something far too large to be absorbed in one glance. Watching ships can be strangely instructive in this regard. From shore, a distant vessel often looks tiny, almost absurdly so. It can seem like a toy placed on the water for visual interest. Then you learn that it is an enormous cargo ship, or a ferry carrying hundreds of passengers, or a naval vessel large enough to hold machinery, supplies, crew quarters, and enough organised complexity to make a small town council feel inadequate. The ship has not changed, your scale reading has. The sea has reduced a giant object to a speck simply by giving it enough surrounding space. That is one of the clearest signs of how badly our ordinary instincts perform at the coast. When something the size of a building appears decorative, the environment around it is no longer operating in familiar proportions. There is a similar lesson in watching land disappear from a boat. Near the coast, land feels stable and near. You can still pick out features: a lighthouse, a row of buildings, a cliff line, perhaps a tower or a stand of trees. But as you move farther out, the coast begins to flatten, shrink, and eventually sink below the horizon. Not vanish in a dramatic curtain of mist, just gradually lose height from the bottom up, as though the world were quietly folding it away. This is one of the most physical ways a person can begin to sense the curvature involved in all of this. The sea is not merely stretching flat into the distance. The planet itself is shaping what can and cannot be seen. Night changes the experience again. In darkness, the visual limit collapses inward. The horizon disappears unless moonlight or distant ships restore part of it. The sea may sound immense and feel close, but its form becomes uncertain. Without the line between sky and water, the mind loses one of its main organising structures. Some people find this calming, others do not, quite understandably. The ocean at night strips away the illusion of easy visibility and replaces it with something more honest. You're beside a large body of water and your senses are not fully equipped to describe it. That uncertainty is not a flaw in perception. It is part of the truth. Fog does something similar by day. A fogged coast can make the sea seem smaller at first because the visible space contracts. You no longer see the long stretch outward, so the ocean feels enclosed. Yet emotionally it can feel larger at the same time because its boundaries have become uncertain. This is one of the fascinating things about sensed size. It is not purely geometric. What we can measure and what we feel are not always aligned. A clear horizon offers a longer visible reach, but a foggy sea can feel more immense simply because it denies closure. The mind does not know where to stop. Children often reveal this better than adults. A child at the shore does not usually think in nautical miles or planetary coverage. They think in direct physical terms. The sea is cold, the waves are strong, the water keeps coming, the horizon is far. They run in and out of it, fascinated by the repeated advance of something larger than they are. In a sense, that is a more honest beginning than many adult concepts of the sea. The body first learns ocean size through mismatch. The wave is bigger than expected. The pull is stronger than expected. The cold is sharper than expected. The sound is louder than expected. The ocean announces scale by quietly defeating confident assumptions. Adults, meanwhile, often arrive with habits that interfere. We have seen coasts in photographs, films, postcards, advertisements, wallpapers, weather reports, and 1,000 passing images online. Familiarity makes the sea look ordinary before we meet it. Then we arrive at a real shoreline and discover that the air has weight. The sound fills space differently, the wind carries spray, and the water extends with a seriousness no screen ever conveyed. This is not because cameras fail completely. It is because flat images cannot reproduce the body's sense of being placed beside something that ignores built environments, schedules, and ordinary urban proportions. Even a long walk along the coast can create a false sense of mastery. You may walk for an hour or two beside the sea, watching it shift from one angle to another, passing dunes, piers, rock pools, dogs with heroic opinions about sticks, and families negotiating towels as though they were diplomatic territory. The shoreline changes, the beach curves, the light alters. You feel you have spent real time with the sea, and you have, but the ocean has barely noticed. You have covered a tiny local edge of an enormous system. The intimacy of the experience is real. Its representativeness is not. That is perhaps the clearest way to put it. The size we can actually sense from shore is meaningful, but it is not representative. It tells us what the ocean is like to meet, not what the ocean is like in total. It tells us how the sea feels against human scale, not how the sea compares with the planet. The shoreline offers emotion, texture, and immediate truth. It does not offer completeness. And that incompleteness is important, because once we admit it, the next step becomes easier. We stop asking the coast to answer the entire question. We let the beach be the beach, the horizon be the horizon, and the body be what it is, a local instrument trying bravely to interpret something global. From there, the ocean begins to open properly, not just as a scene we stand beside, but as a physical fact of Earth itself, one so large that to understand it honestly we have to leave the shoreline behind for a moment and look at the whole planet the way geography eventually forces us to. If you want to understand the true size of the ocean, there comes a point where the shoreline stops being enough, the horizon stops being useful, and even the memory of standing beside the sea has to give way to something larger and less personal. You have to pull back, far enough that beaches disappear, coastlines become outlines, and the earth stops looking like a place made mainly of land with some water around it. Because that is one of the oldest visual habits we carry without noticing. We tend to imagine the planet from the perspective of where we live, and most of us live on land, build on land, drive on land, grow food on land, argue on land, drop our keys on land, and generally behave as though land is the main business of Earth and the ocean is the blue part left over. But once you step outside that habit, even just mentally, the proportions begin to change. The Earth is not mostly land, it is mostly ocean. That sounds simple, almost too simple, as if it ought to have settled itself fully in the mind the first time we learned it in school. And yet it rarely does. We hear it, nod politely, and continue picturing the world in continental terms. Europe here, Africa there, the Americas over that side, Asia spreading across the top like it has somewhere important to be. The oceans become what lies between the continents, which is a bit like describing most of a house as the bits between the furniture. The truth is much less flattering to our land-centred instincts. The ocean covers about 71% of Earth's surface. Land accounts for the remaining 29% or so. That means that if you could somehow step away from the planet and look at it with no emotional attachment to coastlines, no preference for roads, cities, borders, or mountain holidays, you would not call Earth a land world with water added. You would call it an ocean world with some continents sticking out. That shift in emphasis matters more than it first appears. Numbers alone can be slippery. 71% sounds precise, but precision is not the same as feeling. The mind hears the figure and accepts it, yet still quietly imagines a planet where land and water are closer to equal than they really are. Perhaps 50-50, perhaps 40-60. Something visually balanced, something comfortable, but 71% is not balanced. It is dominant. It means that the ocean is not one feature among many. It is the main surface environment of this planet, and still, even that can be hard to picture honestly, because we do not experience the Earth as a whole. We experience it in fragments, a flight path, a coastline, a ferry crossing, a map on a wall, a weather report, a globe spun by a bored child who stops it with a finger somewhere in the South Pacific and accidentally lands on a region so open and watery that it looks less like a destination and more like the planet clearing its throat. Human beings are not naturally equipped to feel planetary percentages. We need help. We need comparison. We need perspective. We need to build the picture slowly enough that the brain has time to stop resisting. Start with the most direct point. If Earth's surface were divided into 10 equal parts, a little over 7 of them would be ocean. Fewer than 3 would be land. Imagine that in any ordinary setting, and the imbalance becomes harder to ignore. 10 plates on a table, 7 covered in water and only 3 dry. 10 rooms in a building, 7 flooded and 3 habitable, if you forgot to ask important questions during the property viewing. 10 pages in an atlas, 7 blue and only 3 carrying all the forests, deserts, mountains, farms, roads, stadiums, suburbs, ruins, airports, and domestic arguments humanity has ever built for itself. That is the first important correction. We are used to treating land as the default surface of the world because it is the default surface of our lives. But from the planet's point of view, land is the minority condition. Dry ground is the interruption. Continents are the exceptions. What is normal, at least across the outer face of Earth, is ocean. This becomes especially striking when you look at photographs of the planet from space. Not diagrams, not schoolbook sketches, not stylized globes, but real images. Blue dominates, clouds sweep over it, continents cut across it like uneven islands in a much larger system. Even then, the view still understates the point a little, because clouds often hide some of the surface, and because our eye remains drawn toward land out of habit. We recognise shapes we know. Africa, South America, Australia, Greenland behaving suspiciously large on some projections and much more modestly in reality. The eye keeps trying to return to land because land is where our categories live. But the blue remains the main visual fact. There is something almost humbling about that. Every city ever built, every road ever laid, every empire, every farm, every village, every train station, every schoolyard, every monument, every football pitch, every traffic jam, every wedding cake disaster, all of it has taken place on the smaller share of Earth's outer surface. The majority of the visible planet is water, not decorative water, not accidental water, ocean. It also helps to remember that the ocean is connected. This is one of those facts that sounds obvious, until you realise how rarely we let it shape our thinking. We talk about the Pacific, the Atlantic, the Indian, the Southern, the Arctic, as though these are separate things in the way that countries are separate or lakes are separate, but they are divisions within one global ocean. Useful divisions, certainly, important for navigation, climate, science, and naming rights, which human beings are always very keen on. But physically, the ocean is one connected body of salt water wrapping around the planet. That matters because when you say the ocean covers 71% of Earth, you're not imagining several unrelated blue patches occupying space between land masses. You're imagining one immense continuous water system spread over most of the world. A connected planetary body so large that the names we give its regions are more about our convenience than its actual separateness. From the perspective of a current, or a drifting organism, or a parcel of heat moving through the sea, these divisions can begin to look very human and very provisional. Now, 71% is a percentage, which is useful but still not fully satisfying. Percentages are neat. The ocean is not neat. So it helps to move from ratio to area. The total surface area of Earth is about 510 million square kilometres. Of that, around 361 million square kilometres are covered by ocean. Land makes up roughly 149 million square kilometres. These are large numbers, obviously, but large numbers tend to become strangely numb after a point. Million follows million, kilometre follows kilometre, and before long the brain politely stops reacting. This is not disrespect, it is self-defence. So let the numbers breathe for a moment. 361 million square kilometres of ocean. Try to imagine a square 1 kilometre on each side, something already much larger than a casual walk across town. Then imagine 361 million of those. That is the water-covered area of Earth's surface. All the visible expanse of the Pacific, Atlantic, Indian, Southern and Arctic oceans together. All the coastal waters, open seas, remote basins, storm tracks, calms, gyres and frozen margins. It is such a large area that ordinary travel experience becomes nearly useless as a measuring tool. You do not simply cross that kind of surface in the way you cross a country road or a national border. You commit time, machinery, fuel, planning, weather tolerance, and a degree of patience bordering on philosophical. Land, by comparison, begins to look not small exactly, but concentrated. A great deal is happening on a relatively modest fraction of the surface. And because human civilization is so dense with detail, land can still feel dominant in our imagination. Mountains rise from it, rivers cut through it, cities mark it with lights visible from orbit. Fields, roads, and political lines divide it into recognizable pieces. The ocean from far away can seem smoother and less informative. Yet that visual simplicity hides the fact that it occupies far more of the surface than the ground beneath our feet. There is another way to feel this more honestly. Think of a classroom globe, the kind that spins a little too easily and always seems determined to rotate away just when you're looking for somewhere specific. Now imagine covering the ocean portions with your hand one area at a time. You would keep moving and moving again. The blue keeps returning. The continents are all there, of course, but they interrupt rather than define the whole. Antarctica takes up a great stretch. Eurasia sprawls impressively. Africa holds itself with proper continental confidence. North and South America stretch along their long north-south line. Australia sits farther off, doing its own thing entirely. Yet even with all that land in view, the ocean remains the larger fact. This is one reason the phrase "the blue planet" is not just a pretty label. It is a visual summary of actual proportion. Earth looks blue from space because ocean dominates the surface view. The atmosphere and the scattering of light matter too, of course, but remove the oceans from the picture, and the planet would not earn that nickname with nearly the same confidence. The sea gives Earth much of its outward identity. If another civilization were observing from a distance and taking rough notes, it would not be unreasonable for them to begin with. Mostly water. The ocean's coverage also has consequences far beyond appearance. Because it covers so much of the surface, it plays an outsized role in regulating temperature, moving heat, influencing weather, storing carbon, producing oxygen through marine photosynthetic life, and moderating the climate in ways land alone never could. A planet with 71% ocean does not merely look different from a drier planet. It behaves differently. The atmosphere interacts with water on massive scales. Storms feed from it. Winds shape it. Currents carry energy through it. Land feels like the stage of human life, but the ocean is a major part of the machinery keeping the larger system running. Yet we still persist in imagining the world as if land were central. There are practical reasons for this. We draw borders on land, not on the open sea with quite the same confidence, though we have certainly tried. We live on land. Our myths, languages, architectures, and calendars grew in relation to ground. The ocean has often functioned in culture as edge, route, resource, obstacle, mystery, threat, or promise, depending on who was looking and whether they were currently on a boat. It has been treated as what lies beyond. But from the planet's own geometry, it is not beyond. It is most of what is there. This also changes the way you think about coastlines. A coastline is not just the edge of land. It is the meeting line between the minority surface and the majority surface. That gives it a different sort of importance. Coasts are where land-based life most directly encounters the dominant outer environment of Earth. No wonder they have shaped trade, migration, settlement, weather exposure, and imagination so strongly. A coast is not a decorative fringe. It is a planetary border zone, and there are many coasts because there is so much ocean pressing against the land. Continents do not merely sit on a planet with some water around them. They protrude into an enormous connected sea that surrounds, separates, and links them all at once. This can be easy to forget when looking at a map centered on familiar regions. Put Europe in the middle, and Europe feels central. Put the Pacific in the middle, and suddenly the Earth looks like an ocean interrupted by land. Perspective changes the story quickly. There is an old land bias hidden even in our language. We often say people travelled overseas, as though the sea were the thing crossed on the way to the real place. We call remote islands isolated, which from a land perspective they may be, but from an ocean perspective they can be nodes in a vast connected environment. We describe continents as substantial, and oceans as open, as if openness was somehow less real than solid ground. But open is not small. Open is not empty. Open, in the case of the ocean, is the dominant condition of Earth's surface. The imbalance becomes even more interesting when you remember how unevenly land itself is distributed. Much of it lies in the northern hemisphere. The southern hemisphere is especially ocean-heavy. This means that depending on where you centre your mental map, the planet's watery character can look even more dramatic. There are stretches of southern ocean where the continuity of water is extraordinary, where currents circle the globe with relatively little interruption from land. The farther south you look, the more Earth begins to reveal itself as an oceanic world, with continental interruptions rather than the other way around. That southern openness matters physically. Winds sweep differently, waters connect differently. Climate processes gain room to operate across large, uninterrupted surfaces. Again, the sea's coverage is not merely a visual statistic. It shapes the actual behaviour of the planet. The size of the ocean on the surface is one reason Earth has the climate patterns it has, the moderation it has, and the oceanic circulation systems it has. Coverage becomes consequence. It is also worth pausing over how remarkable this makes Earth among the worlds we know. A surface dominated by liquid water is not something to take for granted. To us it is ordinary because it is home. But in planetary terms it is extraordinary. We live on a world where most of the outer surface is covered by a connected ocean system. That fact should perhaps receive more respect than it often does. Instead, many of us spend our days inland checking the weather on our phones, occasionally glancing at satellite images of storms over water, and forgetting that the larger surface of the planet is doing an immense amount of work just beyond the centre of our routines. And even surface is only the beginning. Because once you accept how much of Earth the ocean covers, a second realisation arrives right behind it. The sea is not just spread wide, it is also deep. The 71% figure describes only the skin of the planet. It tells you how much of the outer face is water covered, not how much water there is, not how far that water descends, and certainly not what kind of hidden geography lies beneath it. Coverage is the first correction to our instincts. It is not the last. Still, it is an essential correction. Without it, the mind continues to picture the ocean as surrounding land. With it, the picture begins to reverse. The land is surrounded by ocean. Human life plays out on the smaller exposed share of Earth's surface, while the larger share remains water-covered, moving, storing heat, carrying currents, feeding storms, supporting ecosystems, and shaping the conditions under which the rest of us go about our dry little errands. So when you hear that the ocean covers about 71% of Earth, do not let the figure pass by too quickly. Let it do its work. Let it tilt the familiar image of the world. Let it move the continents slightly out of centre stage. Let it remind you that the blue on the globe is not filler. It is the dominant surface fact of this planet. And once that settles, the next question becomes unavoidable, because a broad ocean is one thing, but a broad ocean with immense hidden depth is another entirely. The surface tells you how much of Earth the sea claims from above. The deeper truth begins when you stop looking across it and start considering how far down it goes. Once you accept that the ocean covers most of the Earth's surface, the next correction arrives almost immediately, and it is a much harder one for the mind to handle. The sea is not only wide, it is deep in a way that ordinary experience barely prepares us for. From the shore, depth is mostly a rumour. You wade in, perhaps you swim a little, perhaps a child near you shouts that it is freezing while continuing to run back into it, for reasons known only to children and penguins, and that feels like contact with the ocean. But the contact is shallow in every sense. The true body of the sea lies below the level where casual experience ends. This is one of the reasons the ocean remains mentally underestimated, even after we learn how much of the planet it covers. Surface area is easier to talk about. You can see it on a globe. You can picture blue spreading across the earth. But depth is where the ocean stops behaving like scenery and starts behaving like a vast hidden volume. It is also where the sea becomes difficult to compare with anything in ordinary life, because very few of us spend time in environments where going downward means entering darkness, cold, pressure, and distance all at once. A lake can be deep, a quarry can be deep, a mine can be deep, even a tall building can give you some sense of vertical scale. But the ocean's depth works differently because it combines sheer descent with the fact that the environment changes completely as you go. It is not just a matter of moving lower, it is a matter of moving into zones so different from the surface that they may as well belong to separate worlds connected by water. The average depth of the ocean is roughly 3.7 kilometers. That alone is already more than many people picture, honestly. An average depth of that size means that if you could somehow smooth the seafloor into a more even shape, the planet would still be holding an immense global layer of water, several kilometers deep across most of its surface, and that is the average, which means a great deal of the sea is deeper still. Some parts are much shallower, of course. Continental shelves near land can be relatively gentle and modest by ocean standards. But once the seafloor drops away into the open ocean basins, the numbers quickly stop feeling friendly. To make that average depth feel more real, it helps to compare it with things we think we know. 3.7 kilometers is taller than most buildings by a frankly embarrassing margin. It is higher than many hills people would happily describe as proper mountains after a long walk. If you took a city centre and imagined lowering it underwater until rooftops, towers and cranes all vanished beneath the surface, with more than enough water still above them, you would only just be starting to get the point. The ocean is not a shallow film spread across the planet. It is a deep body holding a hidden landscape below. And then there are the deepest parts. The deepest known point in the ocean lies in the Mariana Trench in the Western Pacific, in a region called Challenger Deep. It reaches to nearly 11 kilometers below sea level. This is one of those figures that can sound dramatic without becoming meaningful unless you pause and make it misbehave in your imagination for a moment. Mount Everest, measured from sea level to summit, is not as tall as Challenger Deep is deep. Put Everest into that trench, and there would still be water above the summit. That comparison has become almost standard, because it is one of the few that reliably makes people stop and recalibrate. It should. A depression in the seafloor capable of swallowing the highest mountain on land with room to spare is not a detail. It is a statement about the scale of the planet's hidden structure. Yet even that famous trench can distort the picture if it becomes the only depth fact people remember. The Mariana Trench is exceptional. It is not what most of the seafloor looks like. The ocean is not one giant pit. It is a vast system of shelves, slopes, plains, ridges, seamounts, trenches, plateaus and basins, each contributing differently to the overall depth. But the trench remains useful because it forces the imagination to admit that the ocean goes far beyond the swimming and boat stage of understanding. There are places in the sea where depth stops being a number and starts becoming an environment that resists ordinary thought. The descent from the surface into that environment does not happen all at once. The ocean is layered, and those layers matter. Near the top is the sunlit zone, the upper part of the ocean where sunlight penetrates strongly enough for photosynthesis. This is where much of the visible marine life familiar to us operates. Fish schools, reefs, drifting plankton near the light, sea turtles, dolphins, and the general business of life in a world that still has a sky above it. It is the part most people imagine when they think of the sea, partly because it is where humans can go most easily, partly because it is where colour still makes sense. The sunlit zone usually extends down to about 200 metres, though the exact depth varies with water clarity, season, and local conditions. 200 meters is already deeper than many people ever directly experience, but in ocean terms it is merely the upper layer, a bright skin over something much larger. This is where the sea still behaves in ways we find familiar. Light falls through it. Surface weather influences it visibly. Plants and microscopic algae use sunlight here. Many of the food webs we think of as marine life begin in this zone because light allows primary production to happen. Below that, the light begins to fail, not vanish instantly, but thin out. Colours change, visibility shifts. The ocean enters a dimmer region often called the twilight zone, extending from roughly 200 metres down to about 1,000 metres. This is one of the most interesting parts of the sea because it is neither surface nor abyss. It is a transition zone, and transitions are usually where nature gets particularly inventive. Too deep for easy sunlight, too shallow to be the deepest dark. Creatures here often rely on faint light from above, on bioluminescence, on migration up and down through the water column, and on strategies that make the surface world look almost administratively simple. The twilight zone matters because it reveals how quickly the ocean changes with depth. At the beach, water is water. Go down a few hundred meters, and water becomes habitat under very different rules. Light no longer supports photosynthesis the way it does at the top. Pressure rises steadily. Temperatures often drop. The surface becomes remote. The idea that the ocean is one uniform mass begins to break apart, which is exactly what should happen if you are trying to understand its size honestly. Large things are rarely simple throughout. Then comes the deep ocean proper, the midnight zone and beyond, where sunlight no longer penetrates. Below about 1,000 meters, the sea becomes dark in the ordinary sense. Not gloomy, not shadowy, dark. Day and night at the surface do not matter down there in the way they matter to us. The sun exists, but not as a visible force. That alone is difficult for a surface creature to take in. Most of the ocean's volume lies in darkness. Most of the sea is not lit. The familiar glittering surface we associate with the ocean is only the exposed top of a vast, dim and dark body. This darkness is paired with pressure, and pressure is perhaps the least intuitive part of ocean depth. For people who have not had reason to think about it closely, water is heavy. We know this in a casual way when lifting buckets, pushing through waves, or realising that moving a filled bathtub would require a strong sense of commitment and probably professional help. But the cumulative weight of kilometres of water is another matter. Pressure in the ocean increases by about 1 atmosphere for every 10 metres of depth. At 10 metres, the pressure is roughly double what it is at the surface. At 100 metres, it is far greater. By the time you reach the deepest trenches, the pressure becomes crushing in the most literal sense. This is why exploring the deep ocean requires specialised equipment. The surface world does not simply continue downward with scuba gear and optimism. Submersibles, remotely operated vehicles, reinforced housings, pressure-resistant materials, careful engineering, and a refusal to take shortcuts become necessary very quickly. The deep ocean is not inaccessible because humans lack interest. It is inaccessible because physics has standards. A machine designed for the deepest sea must survive conditions that would destroy ordinary craft immediately. Even small failures matter when the surrounding water is pushing with that kind of force. Temperature changes too. Much of the deep ocean is cold, often hovering near freezing, though not frozen because of salinity and pressure conditions. This means that as you go down, the sea tends to become darker, colder, and more pressurized, while the food supply often becomes sparser unless you are near special environments like hydrothermal vents or regions of concentrated biological activity. Again, this matters for scale because it means depth is not merely empty extension. It is structured environment, with each layer setting different terms for life and motion. There is also the thermocline to consider, one of those wonderfully important things that most people do not spend enough time discussing at dinner. The thermocline is a layer in the ocean where temperature changes rapidly with depth. Near the surface, Waters warmed by the sun may be relatively mild or even warm depending on region and season. Go deeper, and temperature can fall quite sharply across a relatively narrow band before stabilising in the colder, deep layers below. This creates a kind of boundary in the sea, not a hard wall of course, but a real change in physical conditions that affect circulation, biology, and how the ocean stores heat. That heat storage is one of the reasons the ocean matters so much to climate. Because it is deep, the sea can absorb enormous amounts of heat. The surface warms and cools more quickly, but the deeper ocean acts as a massive reservoir. A shallow ocean-covered world would behave differently. Earth's climate works in part because the ocean is both wide and deep, able to take in heat, move it around, and release it over time. Depth is not just a visual or geographical fact, it is a planetary operating system, and the deep sea is not still in the way people sometimes imagine. The surface is full of visible movement, yes, but the depths are active too. Water masses circulate. Cold, dense water sinks in some regions and helps drive global circulation patterns. Nutrients move. Marine snow, tiny particles of organic matter drifting downward, feeds deeper ecosystems. Creatures migrate vertically, sometimes by astonishing distances. Sediments settle. Geological processes shape the seafloor. The deep ocean may look calm in certain camera footage, but calm is not the same thing as inactive. It is a working environment, just one operating on terms far removed from daily human sensation. One of the most effective ways to appreciate ocean depth is to imagine removing the water entirely. This is not a practical proposal, and it would create a number of issues, to put it mildly, but as a thought experiment it is useful. If the oceans vanished, what would be revealed would not be a flat exposed basin waiting politely at the bottom. You would see a planetary landscape of staggering relief, continental shelves stepping downward from land, slopes descending into the basins, abyssal plains spreading over huge distances, mid-ocean ridges winding around the globe like the seams of a baseball designed by geologists with very ambitious tastes, trenches slicing deep into the crust, seamounts rising from the floor, plateaus and fracture zones adding further complexity. The hidden earth beneath the sea is not minor scenery. It is one of the largest landscapes on the planet concealed by water. That concealment changes how humans relate to it. On land, depth is often something you see from above. A canyon, a valley, a cliff drop. The shape announces itself. In the ocean, depth hides under a moving surface that often reveals almost nothing. You can sail across several kilometres of water depth with no obvious visual clue. The sea may be calm, the sky may be bright, a cup of tea may be involved. Beneath you, the world may fall away into darkness large enough to swallow mountain ranges. It is hard to think of another place in ordinary human experience where such a mismatch exists between surface appearance and vertical reality. This is one reason deep-sea exploration retains such fascination. Space gets much of the glamour, understandably. It has rockets, it has photographs with stars in them, it has the advantage of being visibly elsewhere. But the deep ocean is also elsewhere, in practical terms. It is here on Earth, yet inaccessible enough, alien enough in conditions, and vast enough in unknowns to feel like another realm entirely. The main difference is that instead of a vacuum and radiation, you get crushing pressure, darkness, and creatures that often look as though evolution was working late, and chose not to explain itself. Bioluminescent organisms, for example, are one of the deep sea's great reminders that darkness does not mean emptiness. Many deep sea animals produce their own light. They use it to attract prey, avoid predators, find mates, or confuse anything trying to eat them, which is a perfectly respectable career strategy. In a place where sunlight never reaches, life finds ways to generate signals of its own. This matters not because it is merely strange, though it certainly is strange in a satisfying way, but because it shows how much of the ocean's living reality exists beyond the range of surface intuition. The deepest parts, the Hadal zone in the trenches, push this even further. These are not just deeper versions of the upper sea. They are extreme environments shaped by geology as much as by water. Trenches form where tectonic plates interact, and the depths involved create isolated conditions unlike most of the open ocean floor. Organisms there are adapted to pressure levels so great that simply bringing them upward can damage or destroy them, because their bodies are tuned to conditions we would consider absurdly hostile. Life, once again, refuses to read our assumptions before getting on with things, and still, for all the drama of the deepest zones, the broader point remains simple. The ocean's depth multiplies its size in a way surface thinking cannot capture. A broad, shallow sea would already be significant. Earth's ocean is broad and deep, which makes it far more than a blue covering on the globe. It is a massive three-dimensional body whose uppermost layer is the part we know best, and whose greatest volume exists far below ordinary awareness. This is why even phrases like sea level can be quietly deceptive. Sea level sounds like a baseline, a reference point, a neat global standard, and for many purposes it is. But from another angle, sea level is the top of an immense hidden world. It is not just the line where oceans begin. It is the upper boundary of a vast submerged landscape and water column that extends downward into cold, darkness, pressure, and geological structure over distances that rival the tallest mountains in reverse. So when we say the ocean is deep, that should never be heard as a decorative adjective. It is not the kind of deep that means a lot of water. It means layered environments. It means light fading by the hundreds of meters. It means pressure rising relentlessly. It means an average depth measured in kilometers. It means trenches deeper than the height of Everest. It means that most of the ocean's volume exists in conditions no human can enter unaided. It means that beneath the bright familiar surface lies a vertical world large enough to change how you think about the planet. And once that has settled in, another shift becomes possible, because depth alone is only part of the story. Water fills these depths, yes, but the water is not hanging over nothing. Underneath it lies geography on a scale that would command attention even if it were dry land. Mountain ranges, ridges, plains, slopes, trenches, and volcanic features shape the hidden floor of the ocean, and once you begin to picture that submerged terrain properly, the sea stops looking like a mere body of water and starts revealing the enormous concealed architecture that supports it. One of the easiest mistakes to make about the ocean is to imagine that beneath all that water there is something simple waiting at the bottom. Perhaps a broad flat basin, perhaps a gently sloping floor, perhaps, if we are being slightly more imaginative, a few rocks, some sand, and the occasional shipwreck placed at convenient intervals for documentaries. It is a very understandable mistake. After all, when you look out across the sea, the surface gives very little away. It moves, shines, darkens, reflects clouds, throws waves at the coast, and generally keeps busy enough to distract from the question of what lies under it. But the hidden floor of the ocean is not simple at all. It is one of the largest landscapes on Earth, and if all the water vanished tomorrow, the exposed seafloor would not look like an empty bowl. It would look like a planet-sized terrain of cliffs, ridges, plains, trenches, volcanoes, slopes, and mountain chains extensive enough to make any ordinary hiking map feel a little self-important. That is one of the great quiet facts of Earth. Some of the most dramatic geography on the planet is out of sight almost all the time. We tend to give our admiration to what rises above sea level, because that is what we can visit with a backpack, a camera, and a slightly overconfident weather plan. Mountains get noticed, canyons get noticed. Deserts, valleys, forests, and glaciers all receive their share of postcards and alarming footwear. But below the ocean is a second landscape vast beyond everyday instinct, and it does not receive nearly enough casual attention simply because water is doing an excellent job of hiding it. The first part of that hidden geography begins right where the land leaves off. Continents do not usually drop straight into the deep ocean like a table edge. They extend outward underwater across what is called the continental shelf. This shelf is the submerged borderland of the continents, the broad, shallow area that can stretch outward from the coastline for tens or even hundreds of kilometres before the depth begins increasing much more sharply. If you could drain the sea around a continent, you would not find the land ending neatly at the beach. You would find that the continent continues outward beneath the water in a shallower platform, like the edge of a very large, partly submerged table. These continental shelves matter enormously. They are relatively shallow by ocean standards, which means sunlight can still reach much of the water above them. They tend to be rich in marine life, important for fisheries, and central to many coastal ecosystems humans rely on whether they think about them much or not. They're also where a great deal of human marine activity takes place because they are more accessible than the deeper ocean beyond. The shelf is the part of the seafloor that remains closest to our daily concept of what a coast means. But even here, scale can be misleading. A shelf may seem like a modest underwater margin on a map. In reality, some are immense stretches of submerged continent. Then comes the continental slope, and this is where the hidden landscape begins to change its voice a little. The slope marks the point where the shelf ends and the seafloor drops away much more steeply toward the deep ocean basins. This is not always a dramatic cliff in the cinematic sense, though in places it can be impressively abrupt. More often, it is a long, serious descent marking the real edge between the shallow margin of the continent and the deep seafloor beyond. Think of it as the place where the underwater continent finally gives up trying to be nearby and starts sending you toward the larger oceanic world. These slopes are important not just geographically but dynamically. Sediment moves down them, submarine canyons can cut through them, water masses interact across them. They can be sites of landslides on a scale difficult to imagine on land. A slope hidden under the sea may not get much tourist attention, but it plays a role in moving material from the continental margins into the deeper parts of the ocean. In a sense, it is one of the great transfer zones of the planet, connecting shallow coastal seas to the vast deep basins beyond. And submarine canyons, those deserve a pause. Many people are familiar with canyons on land. Dry, visible, dramatic, easy to admire from a lookout point while holding a drink and pretending geology is part of your personality. But the ocean has canyons too, carved into the continental shelf and slope, some of them enormous. These undersea canyons can rival or exceed many famous land canyons in size, yet most people never picture them because they are hidden beneath water. Monterey Canyon off California, for example, is an immense underwater canyon system that cuts deeply into the continental margin. It is not an oddity. It is part of a broader truth that the seafloor has just as much right to rugged topography as land does. It simply lacks the usual audience. Move farther down from the slopes and you reach the abyssal plains, which are among the flattest and most extensive regions on Earth. That sentence often surprises people, because after all the talk of slopes and canyons and trenches, one begins to imagine the seafloor as permanently dramatic, all sharp drops and volcanic theatrics. But much of the deep ocean floor is actually broad and remarkably flat. These abyssal plains are huge stretches of seafloor, buried under fine sediments that have settled slowly over immense spans of time. Dust from land, remains of tiny marine organisms, particles drifting downward through the water column, all of it accumulates and smooths the terrain. The result is a landscape that, if exposed, might look less like a jagged mountain wilderness and more like an enormous muted plain extending farther than the eye could hold. But even these plains are not simple in the everyday sense. They exist at great depth, under immense pressure, in darkness, and over vast distances. Flatness in the abyss is not the same as flatness in a field behind someone's farmhouse. The nearest point of reference is often very far away. The silence is different. The scale is different. A plain on land can be crossed by roads, fences, and weather fronts you can watch coming. An abyssal plain lies under kilometres of water, far from sunlight, with the nearest ridge, trench, or seamount perhaps still many kilometres off. It is one of the most alien ordinary landscapes on the planet, if that combination makes sense. Ordinary because it is widespread, alien because almost no human being will ever directly experience it. And then there are the mid-ocean ridges, which may be the greatest hidden mountain system most people do not think about often enough. Running through the world's oceans is a connected global ridge system where tectonic plates are moving apart and new oceanic crust is being formed. This is not a local feature, it is a planetary one. The mid-ocean ridge system stretches for tens of thousands of kilometres, making it the longest mountain chain on Earth. That fact alone should be enough to force a recalculation in the mind. The longest mountain range on the planet is largely underwater, mostly invisible from daily life, and quietly central to how Earth's crust behaves. These ridges are not just raised lines on a seafloor map. They are huge geological structures with valleys, volcanic activity, fractures, and varied terrain. In some places they rise high enough that their peaks break the surface and form islands. Iceland is the famous example, sitting astride the mid-Atlantic ridge. It is, among other things, a visible piece of an otherwise mostly hidden global feature. Without places like Iceland, many of us might go through life without any proper visual reminder that ocean floors are geologically active, rising and splitting and shaping themselves continuously under the water. The idea that new crust is forming along these ridges also changes how you picture the sea floor. It is not just a passive floor waiting patiently under the sea. It is part of the Earth's tectonic engine. Magma rises, cools, forms new crust, and that crust gradually moves away from the ridge over time. The ocean basins are not static containers. They are dynamic geological systems. The seafloor is being created, altered, and eventually recycled in different places through plate tectonics. Once you understand that, the ocean starts looking less like a body of water sitting on top of the Earth and more like a major expression of how the planet itself works. Hydrothermal vents are part of that same story, and they are another excellent reminder that the deep seafloor is not quiet in the lifeless sense. Along some ridge systems and volcanically active areas, seawater seeps down into the crust, becomes heated by underlying magma, and then rises back out carrying minerals. The result can be hydrothermal vent systems, including what are often called black smokers, where superheated mineral-rich water pours into the cold deep ocean. Around these vents, ecosystems can form that do not depend on sunlight but on chemosynthesis, with microbes making use of chemical energy instead. Tube worms, clams, shrimp and other organisms can gather around these vents in communities that, when first discovered, made it very difficult to keep saying things like, "life needs sunlight," without adding several important footnotes. That matters geographically as well as biologically. Hydrothermal vent fields turn parts of the seafloor into active, mineral-rich environments, unlike the surrounding plains. They are proof that the hidden geography below is not just shaped by old processes that happened long ago. It is being actively modified now. Heat is moving, fluids are circulating, crust is cracking, chemistry is changing. The bottom of the ocean is not a static basement. It is more like an industrial zone run by geology and microorganisms with absolutely no regard for whether humans find the arrangement convenient. Then there are seamounts, which are underwater mountains rising from the seafloor, usually of volcanic origin. There are believed to be vast numbers of them, many still unmapped in detail. Some are isolated cones, others form chains. A few rise high enough to become islands if they breach the surface, but most remain submerged. This means that the seafloor is not only full of major global structures like ridges and trenches, but also crowded with standalone elevations, some of them very large indeed. A seamount may rise thousands of meters above the surrounding seafloor and still remain entirely underwater. Again, the ocean quietly does this sort of thing often. It hides mountains tall enough to matter very much and then acts as if nothing unusual is going on. Seamounts are important for marine life too because they alter currents and create habitats. Water flowing around them can bring nutrients upward, making these underwater mountains biological hotspots in parts of the ocean that might otherwise be relatively sparse. This is another pattern that comes up repeatedly in ocean geography. Physical structure shapes living systems. The form of the seafloor influences where nutrients move, where organisms gather, and how ecosystems develop. The hidden terrain below does not merely sit under marine life, it helps organise it. Volcanic plateaus also exist on the seafloor, broad elevated regions formed by massive outpourings of lava in the geological past. Some oceanic plateaus are vast, and their existence further breaks the idea that the deep sea is one continuous smooth basin. It is patchy, structured, and historically busy. There have been episodes in Earth's past when volcanic activity built large features under the sea on scales that are difficult to picture, unless you are willing to imagine lava being much more committed to the task than most of us would have guessed. And then, of course, there are trenches. Trenches are perhaps the most famous dramatic features of the seafloor because they are so extreme. These are long, narrow, deep depressions formed at convergent plate boundaries, where one tectonic plate is being forced beneath another. The Mariana Trench gets all the celebrity treatment, understandably, but it is not the only trench. There are trenches in several parts of the world's oceans, and together they show that the seafloor includes not just mountains and plains, but cuts into the crust of astonishing depth. A trench is not merely a deeper patch of ocean floor. It is a major structural feature in the architecture of the planet. What makes trenches especially unsettling to picture is how little surface appearance helps you guess they are there. A ship can pass over a trench and see only surface water. The waves do not politely indicate that below lies one of the deepest places on Earth. That mismatch between the calm visible top and the extreme terrain below is one of the ocean's most persistent habits. It keeps reminding us that surface impressions are poor guides to underlying reality. The hidden geography also includes fracture zones and transform faults, places where pieces of the crust slide past one another, or where spreading centres are offset. These features can stretch for enormous distances across the seafloor, recording the motion of tectonic plates over time. On a map of the ocean floor, some of these lineations run so long and straight that they look almost drawn in by intention, as if the Earth had briefly decided to become an engineer. They are signs that the seafloor is not just rough or varied at random, it is structured by deep planetary mechanics. Sediment adds another layer to all this. Over time, material settles onto the seafloor from above. Tiny shells, microscopic skeletons, dust, volcanic ash, bits of organic debris, all gradually accumulate. In some places, this builds thick blankets of sediment that smooth over the underlying crust. In others, rocky structures remain more exposed. This means the visible shape of the seafloor, if we could see it directly everywhere, would be partly geological and partly the result of long, slow burial. A ridge may be softened by sediment, a basin may be filled. A plain may owe its flatness not to a lack of underlying structure, but to the quiet persistence of material settling over millions of years. This is one reason mapping the seafloor took and continues to take so much effort. For most of human history, we knew coastlines far better than ocean floors, because one is visible and the other is not, which is the kind of challenge surveyors tend to notice. Early mariners could measure depth locally using sounding lines, basically weighted lines lowered into the water. Useful, but limited. It gave points, not full landscapes. Only with sonar and later more advanced technologies did the broad shape of the seafloor begin to emerge with real detail. And even now, not every part of the ocean floor has been mapped at the highest resolutions. We know much more than we once did, but the hidden geography is still being filled in, refined, corrected, and revealed. There is something almost endearing about how recently the full scale of this hidden world became visible to science. People have crossed oceans for thousands of years. They have fished them, feared them, traded across them, fought on them, and written long emotional letters about them. Yet a detailed global understanding of what lies beneath much of that water is relatively new and still incomplete. It is a reminder that living on a planet is not the same thing as knowing it well. If you could somehow stand above the drained ocean floor and look across it, the planet might feel startlingly unfamiliar. The continents would remain, of course, now bordered by wide, exposed shelves. Beyond them, slopes would descend into the Great Basins, ridges would snake around the globe, seamount chains would rise from the plains, trenches would cut deep scars into the crust. Vast flat regions would stretch between more dramatic features. Entire areas we now think of simply as the Atlantic or the Pacific would become revealed as terrains with distinct architecture, not blank spaces, but places with form and history. In a strange way, this hidden geography makes the ocean larger than water alone would suggest. It is not just that the sea is wide and deep, it is that under its surface lies a second world of terrain, one that would be considered extraordinary if it were dry land. We are not dealing with a featureless mass. We are dealing with water draped over one of the most extensive landscapes on Earth. The ocean's size is therefore not only a matter of volume or area, it is also a matter of how much planetary structure it conceals. That concealment changes our emotional relationship to it. On land, large features demand attention. A mountain announces itself. A canyon interrupts the route. A cliff edge improves or worsens your afternoon depending on your comfort with heights. The seafloor cannot do that directly. It exists below awareness unless we go looking for it with instruments, charts, and a willingness to imagine what cannot normally be seen. That makes the hidden geography of the ocean feel almost unfairly modest. It contains the longest mountain chain on Earth, huge plains, deep trenches, canyons, and volcanic systems, and still manages to present itself to most beachgoers as waves and a horizon. Perhaps that is why learning the shape of the seafloor has such a satisfying effect on the mind. It restores proper complexity. It reminds us that the ocean is not a smooth blue cover placed over the Earth like wrapping paper. It is part of a three-dimensional planet with active crust, shifting plates, and submerged landscapes enormous enough to deserve the same respect we give to the visible land. Once you begin picturing ridges under the Atlantic, trenches in the Pacific, canyons along continental margins, and mountains that never break the surface, the sea becomes harder to shrink in your imagination. And that matters because the more accurately you picture the hidden floor below, the more your own scale starts to shift. A person on a beach can feel small beside the ocean. A person trying to picture the full submerged geography of the planet begins to understand smallness in a much more serious way. Not in a dramatic or gloomy sense, but in a literal one. The distances, depths, and structures involved are so far beyond ordinary human proportion that the next step almost takes itself. Once the hidden architecture of the seafloor comes into view, it becomes much easier to see just how tiny we really are inside the scale of the ocean itself. Once the seafloor stops being an empty idea and starts looking like what it really is, a hidden world of shelves, slopes, plains, ridges, trenches, and mountains, another realization settles in almost on its own. The ocean is not merely large in the way a big object is large. It is large in the way a system is large, in the way a planet-sized environment is large, in the way something can make your normal sense of proportion feel slightly homemade. And that is where the human body begins to look very small indeed. This is not meant in a gloomy way. Small is not an insult. In the right context, small is simply accurate. A person is small compared with a blue whale. A blue whale is small compared with an ocean basin. An ocean basin is one part of a connected global sea covering most of the planet. The mind accepts each step individually, but it rarely takes all the steps in one calm sequence. When it does, the scale becomes harder to ignore. You begin to see that much of what feels large in daily life is large only within human arrangements. A building can dominate a skyline, a ship can dominate a harbour, a city can dominate a map. Put any of those inside the full scale of the ocean, and they begin shrinking quickly, not because they have changed, but because the frame has. That frame matters. Human beings are very good at building human-sized worlds. We make doors our height, chairs our width, streets to fit our vehicles, rooms to fit our voices, and schedules that assume the surrounding universe will respect a meeting at 3 in the afternoon. Even when we build large things, we build them as extensions of our own scale. A cruise ship may be enormous by ordinary standards, tall as a building and full of restaurants, theatres, luggage, corridors, and a number of people all trying to locate the correct elevator at once. But on the open ocean, that same ship can look strangely fragile. Not necessarily unsafe, just reduced. A large vessel at sea often appears less like a master of its environment and more like a temporary arrangement moving through something much larger and older than itself. This shift is one of the clearest ways the ocean corrects us. On land, human engineering often feels dominant. Roads cut through mountains, bridges span rivers, towers rise over cities, dams hold back water with the confidence of concrete, airports flatten space into timetables. We become used to the feeling that if something is large, we can probably build around it, over it, or through it, given enough money, steel, and paperwork. The ocean is a less cooperative partner in that fantasy. It allows us to cross it, certainly. It allows ports, cables, shipping routes, drilling platforms, research vessels, ferries, submarines, and all sorts of ambitious equipment. But it never quite stops reminding us that these are visitors, not rulers. A person on a shoreline senses this in the simplest possible way. Stand with your feet at the edge of the water and let a stronger wave hit your legs. Immediately the body receives a practical lesson in scale. The wave is not especially large in the context of the ocean, but it is larger than your balance expected. It pushes with more force than seems fair for something that looked so decorative from a few steps back. Children discover this early and repeatedly. Adults rediscover it every time they decide, with misplaced confidence, that stepping just a bit farther in will be fine. The sea does not need to be extreme to prove a point. It can do so with one wave and a mildly offended expression from the person now wetter than intended. That physical mismatch grows quickly. A human body is a small thing in open water. Even a confident swimmer is operating at a scale the ocean barely registers. In a pool, swimming feels controlled. In a lake, it may feel expansive. In the sea, especially away from shore, scale starts to press against the imagination. Distances are longer than they look. Swells move under you, whether you ask them to or not. Currents may carry you sideways or outward with no visible sign beyond the fact that land has become less helpfully located. The body, which feels like a complete and capable unit in most environments, becomes suddenly modest in the ocean. Arms and legs that seemed perfectly serviceable on land turn out not to be a full answer to several kilometres of water. This is one reason the ocean inspires both confidence and caution in different people. Some feel energised by the openness. Others feel immediately aware of how little of their usual control applies. Both reactions are sensible. The sea offers room, but it also removes the structures that make us feel proportionate. There are no pavements underfoot, no walls, no nearby corners to turn, no quick exits, no obvious fixed points in open water. Once those disappear, human scale becomes very visible to itself. Even boats, which are our usual solution to the problem of not being naturally ocean-shaped, do not fully restore our usual sense of dominance. A small boat at sea feels small very quickly, which is likely why people in small boats often develop either practical wisdom or excellent storytelling, sometimes both. The rise and fall of the water is enough to remind you that the surface itself is moving under your craft. The horizon remains distant. The wind matters more than it did on shore. The body begins reading size through motion rather than through sight alone. A swell lifts you, lowers you, and repeats the lesson as often as necessary. You're not in a fixed world using a machine. You're in a moving world using a floating compromise. And yet the ocean's scale does not only reduce the body physically, it also reduces our usual sense of distance. Consider how we speak about travel on land. 2 hours by car can feel significant. A full day by train feels substantial. A flight across a country feels long enough to justify expensive snacks and a certain amount of personal reflection. The ocean quietly laughs at these proportions. Crossing major oceanic distances has always required serious time. Even today, with aircraft collapsing hours into manageable inconvenience, the actual water below remains immense. Ships still take days and weeks. Routes are planned around weather, current, fuel, traffic and port schedules. Because the body of water involved is not merely between places, it is itself a vast region. That can be hard to picture because most of us encounter ocean crossing through the convenience layer. We board an airplane, look out a window, perhaps note that there is a lot of water down there, and then distract ourselves with a screen, a drink, or the ongoing mystery of why airplane seats are built as if comfort were a dangerous precedent. The flight compresses the experience so efficiently that the sea below can seem almost abstract. But if you remove the aircraft and return to the actual environment, the scale becomes serious again. The ocean has not become smaller because a jet passed over it in several hours. Human transport has merely become fast enough to skip the feeling of distance. History gives a harsher reminder. For most of human existence, crossing the sea meant confronting its scale directly. Voyages were long, uncertain, weather-bound, and often dangerous in deeply practical ways. The ocean could not be simplified into background. It was the main condition of the journey. Water, food, navigation, storms, ship integrity, currents, winds, illness, and morale all mattered because the environment was too large to bluff. A person at sea for weeks does not think of the ocean the way a person does while looking at it from a hotel balcony. The frame has changed. The sea is no longer scenery. It is the whole surrounding fact. There is a revealing psychological shift that happens when land disappears completely. As long as coast remains in view, even faintly, the human mind keeps one foot in its familiar world. Direction has meaning. Return seems imaginable. The sea, however large, still feels adjacent to land. Once the coast drops below the horizon, that changes. The person is no longer beside the ocean. They are in it. That simple change of preposition contains a great deal of scale. Beside is manageable. In is more serious. In means the ocean is now the surrounding environment in every visible direction. In means the body has lost its visual reference to dry ground. In means that if something goes wrong, the nearest fixed thing may be very far away. This is why the ocean can make even large machines look temporary. Consider a cargo ship. These are among the most substantial moving structures people have built, carrying enormous loads across global routes. In port they look dominant. All steel height, stacked containers, engines, cranes, lights and logistics. Out on the open ocean from a distance, they can appear like small marks on the water. The sea has a way of reducing even our biggest practical achievements to scale cues. It does not do this maliciously. It simply contains enough space around them that their human enormity becomes environmental modesty. Submarines create a similar but more unsettling picture. A submarine is one of the clearest signs that humans have learned to operate inside the ocean, rather than merely on top of it. It is sealed, engineered, pressurized, equipped, and built specifically for a world of depth, darkness, and pressure. It is a triumph of design. It is also still very small compared with the sea it enters. A submarine moving through a massive ocean basin is not unlike a single creature passing through a forest too large to walk across. It is competent, yes. It belongs there only by preparation, not by scale. The same is true for divers. Recreational divers often describe the ocean as immersive, quiet, and strangely absorbing, and that makes sense. Underwater, the body begins to leave its usual terrestrial assumptions behind. Direction changes meaning. Up and down become more immediate. Sound travels differently. Breathing becomes mechanical and deliberate. distances can be harder to judge, and even at relatively modest depths by ocean standards, the body feels itself entering an environment in which it is clearly a visitor. Divers are not becoming part of the sea in any fully natural sense. They are borrowing access under carefully managed conditions. The equipment makes the point rather nicely. If an environment requires you to carry your own breathable atmosphere, it is probably larger and less accommodating than your instincts first suggested. Scale also becomes obvious when you start thinking about the life the ocean supports. A whale is one of the few creatures that can make a human being feel small without assistance from architecture. Stand near a life-sized model of a blue whale in a museum, and you already begin to understand how limited your own proportions are. Now place the real animal back into the actual ocean, where it is not in a gallery, but in a moving three-dimensional world extending over great distances and depths. The whale remains huge by biological standards, of course, but the fact that an animal so large can live, feed, migrate and disappear within the ocean tells you something further about the scale of its environment. If something the size of a blue whale can vanish into the sea and become difficult to locate, then the sea is operating on terms far beyond ordinary creature-based intuition. Schools of fish do the same in a different way. Millions of individuals moving through a water body large enough to sustain them do not make the ocean feel crowded. They make it feel capable. The same is true of migrations. Sea turtles crossing entire ocean basins, tuna travelling huge distances, whales moving between feeding and breeding grounds, seabirds following marine productivity across remote waters. All of this hints at an environment where long-range movement is not exceptional, but built into the way life functions. A pigeon crossing a city is one thing, a whale crossing an ocean is another. The scale of the habitat makes different kinds of life possible. Even weather is enlarged by the sea. A storm over land may be destructive, dramatic, and deeply inconvenient for anyone who left laundry outside. But a storm gathering over a wide stretch of warm ocean can build over time and space in ways that land tends to interrupt. Hurricanes, typhoons, cyclones. These systems draw power from the sea because there is enough oceanic surface to feed them. That alone is a kind of scale statement. The ocean is large enough not only to hold ships and whales and migrating ecosystems, but to power weather systems visible from space and consequential across continents. There is also the matter of sound, which travels differently and often farther in water than people expect. The ocean is not silent in any absolute sense. It carries the calls of whales, the noise of storms, the crackle of certain marine environments, geological sounds, and increasingly, unfortunately, the growing mechanical noise of human activity. But what matters for scale is that the sea can transmit these signals across great distances. Creatures adapted to that medium can inhabit an acoustic world far larger than the visible one. Human beings tend to privilege sight, but in the ocean other ways of sensing can reveal just how extensive the environment really is. And then there is time, which is another way the ocean makes us feel small. On land, human schedules often dominate our perception. We think in work days, weekends, seasons, election cycles, mortgage terms, school years, and delivery windows. The ocean acknowledges none of these except when forced into paperwork. It works in currents that circulate over long durations, in sediments settling slowly, in coastlines changing over generations, in coral growth, in ice melt, in plate movements shaping basins over immense spans of time, and in storms that may feel sudden to us, but are part of larger patterns. A person standing by the sea feels small, not only in body but in duration. We do not simply encounter a big thing. We encounter a system that operates on timescales broader than our routines. This is perhaps why people often describe the ocean as humbling. That word can sound grand if overused, but in this context it is simply descriptive. The sea removes some of our usual exaggerations about ourselves. It does not do so cruelly. It does not mock. It merely places us in a frame where our normal importance shrinks to proper size. The body becomes small. Our machines become temporary. Our roots become narrow traces. Our timetables become local. Even our maps begin to look a little brave and a little incomplete. At the same time, smallness can be clarifying. The ocean does not only reduce us, it also locates us more honestly. It reminds us that human life unfolds on a minority surface of a mostly ocean-covered planet. It shows that our great achievements, while real and impressive, occur within larger systems of water, climate, geology and biology that we did not make and do not fully control. And strangely, that can be comforting. There is relief in being returned to actual proportion. Not every environment needs to be organised around human convenience. Some can remain large enough to resist being turned into a tidy extension of our habits. Children often understand this before adults dress it up with abstractions. Put a child at the shore with a bucket and a wave will eventually educate the relationship. The child may attempt to collect the sea, shape it, block it, redirect it, or negotiate with it in the form of a sand wall. The sea responds with complete indifference, and another wave. It is a useful lesson, really, charming in small doses. The child learns that the ocean can be touched but not contained. Adults learn the same thing by more elaborate means, usually involving maps, boats, weather forecasts, shipping schedules, and perhaps a strong respect for life jackets. There is one more way the ocean makes us feel small, and it has to do with what we still do not know. A very large thing that is well understood becomes manageable in the mind. A very large thing that remains partly unknown stays larger psychologically than measurement alone might suggest. The sea has this advantage. We know a great deal about it, certainly more than people once did. We can map broad structures, track currents, monitor temperatures, study ecosystems, and send instruments into great depth. Yet large portions of the ocean remain sparsely observed compared with the land. Species are still being discovered. Seafloor detail is still being refined. Deep-sea systems continue to surprise. The ocean is not just big. It is big enough that full familiarity remains out of reach. That combination, measurable and still not fully known, keeps the sea at a proper distance in the imagination. It prevents us from shrinking it too neatly into resource, route, holiday, or view. Those are all real relationships to the ocean, but none of them is the whole. The whole is much larger. It includes widths that take weeks to cross by ship, depths measured in kilometres, hidden mountain chains, trenches deeper than Everest is tall, currents moving heat around the planet, ecosystems adapted to darkness and pressure, and a continuous body of water covering most of Earth's surface. Inside all that, a person is very small, not meaningless, not powerless in every sense. Human actions can affect the ocean profoundly, as pollution, overfishing, warming, acidification, and noise pollution all make painfully clear. Small does not mean harmless, and it certainly does not mean irrelevant, but it does mean proportionate. It means the body, the boat, the city, the species all occupy a limited place inside something larger than our instincts were designed to picture easily. And once you let that settle, another question begins to form quite naturally. If we are this small inside the ocean's scale, then how much water are we really talking about altogether? Not just in terms of surface or depth, or the feeling of being dwarfed by it, but in total amount. Because the sea does not only surround us and stretch beyond us, it also contains a volume so immense that the mind has to switch from geography to numbers, and then right back to metaphor again just to stay oriented. Once the ocean has become large enough in the mind as area, depth, and hidden geography, there is one more turn the question naturally takes. Width tells you where the sea spreads, depth tells you how far it falls, hidden ridges and trenches tell you what lies beneath. But volume asks something even more blunt. How much water is actually there? That question sounds almost innocent at first. It has a practical ring to it, as though we are about to measure out ingredients for a recipe that has become slightly unreasonable. A cup of flour, a spoon of salt, one entire planetary ocean. Yet the moment you start trying to count the sea in total, human numbers begin behaving strangely. They remain technically correct, of course. Science is good at that. But the mind does not always follow willingly. It hears the figure, nods, and then quietly refuses to feel it properly. The total volume of the world's ocean is about 1.332 billion cubic kilometres of water. That is the sort of number that risks becoming meaningless on arrival unless you give it room to settle. 1,332,000,000 cubic kilometres, not square kilometres, which would already describe an enormous spread of surface. Cubic kilometres, volume, three-dimensional space filled with water, a kilometre in width, a kilometre in length, and a kilometre in depth, repeated more than 1 billion times. That is the ocean. This is where the brain often begins trying to protect itself by becoming casual. Ah, yes, 1 billion cubic kilometres. Quite a lot then. And then it retreats to safer topics like soup or socks, or whether that one email really needed to exist. But if you stay with the number a little longer, it begins to do what good numbers sometimes do. It changes the picture. The ocean stops being just a very wide thing and becomes what it really is, a massive body with enough water in it to resist all ordinary comparison. The difficulty, of course, is that cubic kilometres are not native to human intuition. We're not built to picture them easily. A cubic metre is already a decent amount of space. A cubic kilometre is vastly larger than that, a block of volume so big that if you tried to stand next to it and feel sensible, you would fail almost immediately. So saying the ocean holds more than 1 billion cubic kilometres is scientifically useful and emotionally slippery. It is correct in the way a tax code is correct. Admirable, necessary, and not immediately soothing. So let us try other angles. Imagine for a moment that all the ocean water on Earth could be gathered into a single perfect cube. Not spread across basins, shelves, trenches and coasts. Not moving in currents or breaking at shores. Just one giant block of water suspended in the imagination, which is already doing enough unpaid labour as it is. That cube would be roughly 1,100 kilometres on each side, more than 1,000 kilometres wide, more than 1,000 kilometres long, and more than 1,000 kilometres high. That is not a village pond that got carried away. That is a structure of water large enough to sit over countries, and yet even that cube, dramatic as it sounds, can still be hard to feel because cubes are not how we encounter the sea. We meet the ocean as surface, as weather, as coastline, as horizon, as movement. Volume hides inside that familiar experience. It is present but not visible all at once, which is why the ocean can still surprise people after a lifetime of seeing it. Familiarity with the surface does not automatically create honesty about the amount beneath. Another way to picture the total volume is to imagine what would happen if that water were spread evenly over the entire surface of the Earth, not just the basins where the oceans now sit, but across everything. Continents, plains, mountain ranges, cities, roads, farmland, all of it. If you smooth the planet out and distributed the ocean water evenly across its whole surface, Earth would be covered by a global layer of water roughly 2.6 kilometres deep. Not a puddle, not a flood in the usual sense. A world ocean more than 2.5 kilometres deep wrapped around the entire planet. That is a useful comparison, because it turns a difficult volume into a depth you can at least begin to relate to. Every continent gone under. Every familiar landscape erased beneath a layer of water deeper than many mountains are high above their base terrain. It is not exactly how the Earth is arranged, of course. The actual planet has basins, elevations, ridges, trenches, and all the irregular architecture that makes geography possible. But as a way of feeling the amount of water involved, it helps. The ocean is not merely filling low spots. It represents enough water to bury the whole visible world under a planetary layer of sea. This is also where it becomes useful to remember that the oceans hold about 97% of all the water on Earth. Almost all of the planet's water is in the oceans. The rest exists in glaciers, ice caps, groundwater, lakes, rivers, the atmosphere, living things, and small accessible fractions we tend to care about intensely because they are the fractions we actually drink, irrigate with, build policy around, and argue over. But in the broadest physical sense, Earth's water is overwhelmingly ocean water, salt water, marine water, water held in the big connected system covering most of the surface. That has a strange effect on perspective. We often think of rivers and lakes as the visible representatives of water in daily life. They are, after all, where many people meet fresh water directly. But compared with the oceans, these are tiny fractions. Necessary, precious, consequential fractions certainly, but tiny. If the Earth's water budget were a household account, the ocean would be taking up nearly all the page while rivers and lakes would be trying to make their case in the margins. And yet even the number 97% can hide something important. The sea is not only holding most of the planet's water, it is holding most of it in motion. Water evaporates from the ocean, forms clouds, falls as rain or snow, feeds rivers, enters soils, moves through ice, and eventually much of it returns. The water cycle that supports life on land is deeply tied to the ocean because that is where most of the water resides. The sea is not just a giant storage tank. It is a major operating component in the movement of water through the planet's systems. Volume, then, is not just about quantity. It is about influence. A very large reservoir can do things a small one cannot. It can store heat on enormous scales. It can exchange moisture with the atmosphere over vast surfaces. It can buffer change more slowly, or amplify certain patterns more powerfully, depending on what is happening around it. The ocean's volume is one reason climate behaves the way it does, one reason heat is absorbed and redistributed the way it is, one reason storms can gather force, and one reason the deep sea remains a long-term storehouse for temperature and carbon processes that affect the whole planet. There is another comparison people sometimes reach for when trying to tame the number. Swimming pools. Human beings love comparing impossible quantities to swimming pools because swimming pools are just large enough to feel impressive and just familiar enough to feel manageable. It is a noble effort. A cubic kilometre of water is about 400,000 Olympic-sized swimming pools. Multiply that by 1.332 billion cubic kilometres, and the resulting number of pools becomes so absurdly large that the comparison starts to collapse under its own administrative burden. At that point, you are no longer picturing anything. You are simply counting yourself into a mild philosophical crisis beside a giant imaginary leisure complex. So perhaps it is better to return to the body. The human body understands containers. A glass, a bath, a pool, a lake. These are all water volumes that can, with varying degrees of effort and poor decision-making, be entered, emptied, crossed, or managed. The ocean is not like that. It is not a container in the way those things are containers. It is a world-sized mass filling much of the outer structure of Earth. Volume at that scale stops being something you can mentally pour from one place to another. It becomes a condition of the planet itself. This is why phrases like sea level and rising seas carry so much power. Because the total volume is already immense, relatively modest shifts in where that water is distributed or how it expands can affect coastlines, weather patterns, and ecosystems across very large areas. A great volume of water does not have to move dramatically in one visible gesture to change the world. Tiny percentage shifts in a system this large still represent extraordinary amounts of material. The ocean is simply too big for small changes to remain truly small once spread across planetary scales. And then there is salinity, which adds another layer to the idea of the sea as a counted world of water. Ocean water is not just water in the everyday sense. It is water carrying dissolved salts and minerals, chemically active, density sensitive, shaped by evaporation, freezing, melting, river input, mixing, and circulation. The total volume of the ocean is not one bland universal liquid. It is a vast body with variations in salinity and temperature that matter for how the water moves. Water masses form differently depending on where they are. Cold, salty, dense water sinks in some places. Warm surface waters travel elsewhere. The volume of the sea is therefore not passive bulk. It is organised bulk, moving and layering itself according to physical rules. That organisation is part of why the phrase "counting the ocean" is both useful and slightly misleading. We can estimate volume, yes. We can measure basins, map depth, model circulation, and build increasingly accurate pictures of the total amount of water present. But the sea is not stacked neatly in one giant measuring jug. It exists in interaction with itself. Surface waters mix imperfectly with deeper layers. Currents carry water masses over long distances. Temperature and salinity influence density. The ocean's volume is not only large, it is internally structured in ways that make the whole system behave with complexity rather than simple mass. A useful mental image here is to think less of a full bathtub and more of a global body with internal pathways, layers, and exchanges. Not metaphorically in the grand emotional sense, just physically. Water moves through the sea with enough pattern that oceanographers can track major circulation systems across basins. Heat is carried, nutrients rise and sink, deep currents move slowly, surface currents move differently. The total volume contains not stillness but motion over long scales. It is a world of water, and like most worlds, it has roots. This is also why deep water matters so much. A large fraction of the ocean's volume is far below the familiar surface zone. Most of the sea is not the bright upper layer we imagine when someone says the word ocean. Most of it lies in darker, colder regions where light never reaches. That means most of the actual water by volume exists outside ordinary human experience. People know the ocean through its skin. The body of it remains mostly elsewhere. This is a remarkable fact when you stop to think about it. One of the largest physical realities affecting the planet is, for most of us, largely invisible. It can help to compare this with cities. Imagine living your whole life in the top floor of an enormous building and deciding that you know the building well, because you have seen the roof garden and the entrance hall. That is not nothing, it is a real acquaintance. But it is not the structure. Much of the ocean is like that lower unseen architecture. The visible surface is real, important and active, but it is only the entrance layer to the total volume. Even the shape of the basins matters here. The ocean's volume is distributed through Pacific, Atlantic, Indian, Southern and Arctic regions, each with different proportions, depths, circulation characteristics, and seafloor forms. The Pacific alone holds more water than any other ocean basin. It is so large that it can distort intuition all by itself. If all the oceans feel hard to picture, the Pacific deserves a special mention for making even global maps look slightly apologetic. The Atlantic, while smaller, still contains an immense volume. The Indian Ocean, Southern Ocean, and Arctic each contribute differently to the total body, with their own roles in circulation, climate, and marine life. So the world's ocean volume is not merely a number attached to a single bowl, it is distributed across connected basins of different character, linked in one global system, and there is a strange comfort in that connectedness. The same body of water touches many coasts, enters many climates, and moves through many forms. Water that begins in one region may, over time and through circulation, become part of processes elsewhere. Heat absorbed in one basin can matter far away. Melting ice in one region can affect salinity and circulation in another. The volume of the sea is not simply present. It participates. It links. Humans, of course, have spent centuries trying to make sense of all this with measurement. Depth soundings, charts, surveys, sonar, satellites, remote sensing, autonomous floats, research vessels, computer models. It is an extraordinary effort, and it has revealed an enormous amount. But one reason volume remains such a satisfying idea is that it combines precision with impossibility. We can calculate the figure quite well, and yet no person can truly experience the totality of 1.332 billion cubic kilometres as a felt reality. The number is knowable. The thing itself remains too large for direct comprehension. There is something honest about that. Science can count it. The imagination still has to work for it. And perhaps that is exactly the right balance. Some truths should remain a little larger than the mind can hold in a single pass. Not because they are mystical or vague, but because scale itself has limits when filtered through a creature our size. The ocean does not become less real because it exceeds intuition. It becomes more impressive. Countable, but still not containable by casual thought. This is where volume begins to alter the emotional picture of the sea. A beach can feel personal, a coastline can feel local, a horizon can feel intimate in a quiet way. Even depth, once understood, can remain partly abstract because it belongs to places most people never go. But total volume does something different. It reveals the ocean as one of the main physical facts of the planet. Not a beautiful extra, not a dramatic edge, not a route between real places, a main fact. An immense quantity of water shaping climate, storing heat, holding most of the planet's water, influencing life systems, and occupying a body of space so vast that every ordinary comparison eventually gives up and goes home. And still, numbers alone are not enough. The sea is not large only because of how much water it contains. It is large because within that water there are distances between places, migrations between habitats, currents linking basins, and living things occupying spaces so spread out that emptiness and abundance can exist side by side. Once the volume is in view, another part of the picture begins to matter more clearly. Not just how much water there is, but what moves through it, how far things travel within it, and how much space can lie between one point of life and another in this enormous connected world of salt water. Once you begin to grasp the total volume of the sea, the next temptation is to picture all that water as empty space with a few fish in it, which is understandable, but also wildly unfair to both the fish and the water. Because the ocean is not just large in a geometric sense. It is large as a living and moving environment. It contains creatures ranging from microscopic plankton to animals larger than buses, currents that travel across entire basins, migrations that make most human commutes look faintly ridiculous, and distances between one patch of life and another so great that the mind starts to lose its usual sense of how worlds are arranged. This matters because size on its own is one thing. A desert is large, a mountain range is large, a continent is large. But the ocean adds a different kind of scale because the space is not static, and it is not empty. Water moves through water, life moves through water, heat, nutrients, larvae, predators, prey, drifting plants, sound, and weather influence all move through water. So when we ask how big the ocean really is, part of the answer lies not only in its dimensions, but in the fact that those dimensions are inhabited and connected in ways that are hard to picture from shore. Take currents for a start. Most people know, in a general way, that ocean currents exist. They have heard of the Gulf Stream, perhaps, or have seen maps with arrows curling through the Atlantic and Pacific, like someone tried to explain the sea using decorative ribbons. That is a useful beginning, but only a beginning. A current is not just an arrow on a page. It is moving water on a large scale, often carrying heat, salt, nutrients, and living things with it. Some currents are broad, powerful surface flows driven by wind and Earth's rotation. Others are deeper, slower, shaped by temperature and salinity differences, and tied into the global overturning circulation that helps move water through the planet's oceans over very long timescales. This means the ocean is never really one still thing. Even when the surface looks calm from a beach, larger movements are underway. Water masses travel, boundaries form between warmer and cooler waters, eddies spin off major currents. Nutrients rise in some places and remain trapped deeper in others. A parcel of water does not simply sit obediently where a map first placed it. The ocean is in motion all the time, which is one reason marine life can be so widely spread and yet so unexpectedly concentrated. Currents are, in a sense, the great hidden roads of the sea, though roads is perhaps too neat a word because roads generally stay where they are put and do not decide halfway through the week to bend around a weather system and alter the distribution of heat across half a basin. Still, the comparison helps. If you want to know why some coasts are richer in marine life than others, why some waters stay warmer or colder, why some animals migrate along certain routes, and why floating objects can travel astonishing distances, currents are part of the answer. They structure the ocean without making themselves obvious to casual human senses. A person standing on a shore cannot see the Gulf Stream the way they can see a river. They may feel the weather shaped by it. They may live on a coast influenced by it. But the current itself is not a visible blue lane marked warm water this way. The same is true for many of the ocean's great circulations. They become clear through measurement, temperature patterns, drifting instruments, satellite data, and long scientific effort. Once known, though, they change your picture of the sea. The ocean stops being an enormous tank and starts looking more like a moving body, with circulation, exchange, and pathways. And living things use those pathways constantly. Tiny drifting plankton, which are easy to underestimate because they're tiny and drifting and have a public image problem, are in fact central to the whole arrangement. Phytoplankton, microscopic organisms near the surface, do photosynthesis and form the base of many marine food webs. Zooplankton feed on them and are in turn eaten by larger creatures. Whole systems rise from these minute drifting lives. The ocean can look empty from above, but in productive waters it may be full of microscopic activity dense enough to influence global oxygen production, carbon cycling, and the food available to everything from small fish to giant whales. This is one of the ocean's most reliable tricks. It often looks sparse at the scale of the eye while being abundant at the scale that matters biologically. A person gazing across open water may see very little beyond surface and horizon. Beneath that there may be plankton blooms, fish schools, squid, marine mammals, sinking organic matter, and layers of life arranged according to light, temperature, predation, and current. The sea is often fuller than it looks, and emptier than we expect in the exact places we hoped it would be convenient, which is a very ocean sort of behaviour. Patchiness is part of this. Life in the sea is not spread evenly like raisins in a carefully mixed pudding. It gathers, it clusters around nutrient-rich waters, seamounts, upwelling zones, coasts, reefs, frontal boundaries between water masses, and other productive regions. Then there are vast stretches of open ocean where visible life may seem sparse. This does not mean those waters are dead. It means that ocean scale includes large distances between one hotspot of life and another. A bird crossing such waters may travel far between obvious feeding opportunities. A whale may migrate across huge spans to reach breeding or feeding grounds. A drifting larva may survive only if currents carry it into suitable habitat before time runs out. Distance in the ocean is not just a geographic issue, it is a biological one. Whales make this especially clear. A blue whale is huge by any ordinary standard, so is a humpback. Even smaller whales compared with a blue whale are still large enough to reset your confidence about body size. Yet these animals live in an ocean so extensive that they can disappear into it with ease. Many migrate thousands of kilometres between feeding grounds and breeding grounds. Think about that for a moment. An animal larger than a bus can travel across an ocean basin and still be operating within the normal logic of its species. If the environment can absorb a creature that size into its basic rhythms, then the environment is operating well beyond the scale of land-bound instinct. Sea turtles do something similar in a quieter, more improbable way. Hatchlings emerge from beaches tiny, vulnerable, and somehow expected by evolution to make sense of an oceanic world they have never seen before, which seems like an unreasonable onboarding process. Yet many of them enter vast marine systems, drift or swim through currents, and later return to particular regions to feed or breed. The distances involved can be immense. The guidance mechanisms are still being studied in detail, but the fact itself is enough to make the point. The ocean is not only large, it is navigated by creatures whose entire lives depend on crossing that largeness successfully. Then there are tuna, sharks, eels, salmon, seabirds, and countless other animals whose movements reveal how connected the sea really is. Tuna can travel across large parts of ocean basins in search of food and favourable conditions. Some sharks range widely across open water, crossing political boundaries with the serene indifference only marine animals and weather systems manage properly. Eels begin life in one environment, migrate through another, and perform life cycles so strange that for centuries people remained genuinely confused about where they came from. Seabirds may cover astonishing distances over the open ocean, locating productive feeding areas in a world that would look blank and repetitive to us. This is where the distances between start to matter, as much as the creatures themselves. On land, habitats are often broken into visible patches. Forest here, grassland there, river in between, mountain beyond. In the sea, those divisions can exist, but they are often less obvious to the eye and more defined by temperature, depth, chemistry, productivity, salinity, and current structure. A highly productive region rich with life may lie far from another such region. A reef may flourish near a coast or island, while the open water beyond stretches for hundreds or thousands of kilometres with a completely different ecological logic. An animal moving from one place to another is not crossing empty blue simplicity. It is crossing gradients, layers, and shifting conditions through a space large enough to make migration a defining feature of life. Coral reefs are a good example of contrast. Reefs can be rich, crowded, bright, and busy, full of fish, invertebrates, algae, competition, hiding places, and the general marine equivalent of a very active neighbourhood. They're biologically dense and visually impressive, but a reef, however rich, occupies a relatively small patch compared with the size of the surrounding ocean. Beyond it may lie open water stretching far beyond the horizon. This contrast between intense local abundance and immense surrounding space is central to understanding marine scale. The ocean can contain crowded worlds and vast intervals between them at the same time. Kelp forests, coastal upwelling zones, mangroves, estuaries, deep-sea vent communities, polar feeding grounds, and subtropical gyres all reveal different versions of this pattern. The sea is one connected body, but it is not uniform. It contains regions of productivity and relative scarcity, places of shelter and open transit, routes of migration, and zones of retention. A current may concentrate drifting life in one region and disperse it in another. A seamount may create a gathering point in otherwise open water. A deep canyon off a continental shelf may channel nutrients in ways that affect the life above. Geography and movement combine to create a world where the distances between productive or suitable habitats can be crucial. Even the famous seeming emptiness of the open ocean deserves more respect than it often gets. People sometimes talk about the empty sea when they mean open water with no obvious land or visible abundance. But open ocean is not empty in any literal sense. It may be less visibly crowded than a reef, but it contains plankton, fish, gelatinous animals, squid, marine mammals, drifting debris, vertical migrants, microbes, and layers of life arranged through the water column. It is simply that much of this is spread out or hidden, at scales our eyes do not read easily from the surface. The ocean has a talent for making full places look spare. Vertical distance matters too. It is easy to think only in horizontal terms, crossing from one coast to another, one island to another, one feeding ground to another. But for many marine organisms, the most important journey may be up and down. Every day, one of the largest animal movements on Earth happens in the ocean, as vast numbers of organisms in the deep scattering layer rise toward the surface at night to feed and descend again by day. Tiny creatures, fish, squid, and others take part in this daily vertical migration. The distances involved may not be ocean basin wide in one movement, but the combined scale is enormous. It is another reminder that the sea's size works in 3 dimensions, and its life does too. The creatures of the deep make the scale feel stranger still. In the dark ocean below the sunlit layers, animals live in a world with no sunlight, intense pressure, and often sparse food. Some drift, some hunt, some produce their own light, some wait for organic matter to fall from above. Others gather around hydrothermal vents where chemical energy supports food webs far from the surface. The distance between the beach and a deep-sea vent ecosystem is not just measured in kilometres, it is measured in conditions, in physics, in the kinds of life that can survive there. The same ocean holds both tide pools children poke at with sticks, and communities of organisms living in complete darkness near superheated vent fluids. That should probably be enough to keep anyone humble for at least an afternoon. Currents also connect these layers and habitats in subtle ways. Larvae of many marine species drift for part of their lives before settling in suitable places. Nutrients can be brought upward by upwelling, supporting productivity near the surface. Organic matter falls downward, linking surface food webs to deeper ecosystems. Large animals carry nutrients in their bodies as they migrate. Even death moves through the system in scale-shifting ways. When a large whale dies and sinks, the carcass can feed deep-sea communities for years. In the ocean, distance is bridged not only by swimming but by sinking, drifting, mixing and circulation. The distances between islands offer another useful correction to human scale. On a map, island chains can look pleasantly decorative, as though one might skip among them with a cheerful afternoon available. In reality, many island groups are separated by very large stretches of open water. The Pacific especially is full of distances that make maps look impolite. Polynesian voyagers crossing these waters in sophisticated traditional canoes accomplished feats of navigation that remain astonishing, not because they were merely brave, though they certainly were, but because the oceanic spaces involved were immense and demanded real understanding of stars, swell patterns, birds, winds, and seasonal behaviour. The distances between small points of land in that ocean are enough to make entire cultures of navigation necessary. This is another thing the ocean does. It turns gaps into worlds. The distance between one island and the next is not just a blank line between locations. It is a marine environment full of conditions, movement and uncertainty. For people navigating it, that distance becomes lived space. For animals crossing it, it becomes ecological reality. For currents flowing through it, it becomes part of a larger route. The sea does not really have blanks in the way maps suggest. It has intervals full of process. And then there is the matter of the creatures we have not even properly counted yet. Marine science has identified an enormous range of ocean life, from microbes to giant squid to whales. But the ocean is still turning up surprises. New species continue to be described. Deep-sea ecosystems continue to reveal unfamiliar forms. Even in better-known waters, population sizes, migration routes, and ecological relationships can shift or remain incomplete in our understanding. This matters because when you consider the creatures, currents, and distances together, the ocean begins to look not only large but difficult to summarize honestly. It is too full of movement, too varied in habitat, and too vast in extent to be reduced to one simple image. The human tendency is always to simplify toward the familiar. Beach, fish, wave, boat. Those are real parts of the ocean, but they are only the doorway. The full picture includes microscopic drifters producing oxygen near the surface, vast current systems redistributing heat, migrating whales crossing basins, seabirds tracing feeding zones, larvae travelling invisible routes, reef fish defending tiny territories, sharks moving across open water, deep-sea creatures rising nightly toward food and long distances between one centre of abundance and another. The sea is crowded and spacious at once. That combination is perhaps the best clue to its scale. If the ocean were only large and empty, it would be one kind of vastness. If it were only full and crowded, it would be another, but it is both. It contains long stretches where visible life seems scarce, and concentrated regions where biological activity is intense. It holds giant animals and microscopic ones, local habitats and basin-wide migrations, thick seafloor communities and drifters carried by moving water. It is, in other words, large enough to make both abundance and isolation ordinary features of the same world. And for all the science we now have, there remains something slightly uncanny about that. A person can stand on a shoreline and see very little of it directly. A satellite can look down and see broad patterns, but not everything beneath. A research vessel can sample a region in detail, but still only a region. The ocean resists total visibility. You can study one current, one reef, one trench, one migration route, one bloom, one feeding ground, and still feel the larger sea stretching away beyond the frame. That is where this chapter of the picture naturally leads next. Because once you understand that the ocean is not just wide and deep, but full of moving water, living roots, biological hotspots, and large distances between them, another question becomes harder to avoid. How much of this enormous world do we actually know well? How much of the seafloor has been mapped in real detail? How many species remain to be described? How many processes are still only partly understood? The ocean, after all, is not just large enough to carry currents and creatures across the planet. It is also large enough to keep much of itself just beyond the edge of what we have fully explored. One of the reasons the ocean still feels mysterious is that people often imagine unknown as meaning neglected, as though the sea has remained unexplored because humanity forgot to look. That is not what happened at all. We have looked for a very long time. We have crossed oceans for thousands of years, dropped weighted lines into them, sounded depths, charted coasts, studied tides, tracked currents, lowered instruments, launched submersibles, flown satellites overhead, and sent robots into darkness. The problem is not lack of interest. The problem is that the ocean is enormous, difficult to enter, expensive to study, and physically hostile in ways land usually is not. Even now, the deep sea begins below about 200 meters, where sunlight no longer penetrates well, and from there the environment becomes dark, cold, and high pressure very quickly. That first practical difficulty is depth itself. On land, if scientists want to study a forest, a canyon, or a mountain slope, they can usually go there in person, set up equipment, return regularly, and work with a reasonable sense that the environment is not actively trying to collapse their instruments from every direction. In the ocean, the deeper you go, the less that remains true. Pressure increases by about 1 atmosphere for every 10 meters of depth. At average ocean depth, pressure is roughly 380 times greater than at the surface, and in the deepest trenches it can be around 1,100 times greater. That is not the sort of setting where a person can simply put on boots and have a look around. It requires specialized vehicles, special materials, and engineering with very little room for mistakes. Darkness is another reason the ocean remains partly unknown, and it sounds simpler than it is. We tend to think of darkness as merely poor visibility, like a room where someone forgot to pay the electricity bill. In the deep ocean, darkness is structural. It is permanent in the ordinary sense. Most of the sea lies below the sunlit surface layer, and once you descend far enough, there is no natural light to work with. That means every act of seeing has to be manufactured. Cameras need lights, robots need imaging systems, sonar often has to stand in for vision. Even then, you're not scanning a whole landscape at once. You're illuminating a narrow patch inside a very large world, a bit like trying to understand an entire mountain range by walking through it at night with a torch and a very determined spreadsheet. Cold and corrosive salt water do not help either. The deep sea is not only dark and pressurized, it is also cold enough to stress equipment, harsh on materials and remote from easy repair. If something breaks on a city street, a technician may arrive with tools and mild disappointment. If something fails thousands of meters below the ocean surface, the consequences are rather less manageable. Recovery may be difficult or impossible. This is why deep ocean exploration often moves with careful planning rather than cheerful spontaneity. Every instrument lowered into the sea has to survive not just the journey downward, but pressure, cold, darkness, salt, and the possibility of being very far from help when something decides not to cooperate. Then there is the matter of distance. The ocean is not just hard to enter, it is hard to reach in the first place. Many of the least studied areas are far from ports, far from supply chains, far from calm weather, and far from the places where ships can be supported easily. A land expedition can often stop, resupply, and continue. A ship in remote ocean waters must bring fuel, food, technical support, scientific equipment, data systems, and enough redundancy to cope with long stretches away from shore. That makes expeditions expensive. It also means there are only so many ships, crews, and mission days available in a year, and those resources have to be divided among mapping, biology, geology, climate observation, archaeology, fisheries work, and a long list of other priorities. The ocean stays unknown partly because ship time is finite and the sea is not. Even mapping, which sounds like the most basic first step, takes much longer than people expect. A common misunderstanding is that modern technology must have solved the whole "where is the seafloor and what shape is it?" problem by now. Not quite. NOAA notes that the whole seafloor has been mapped coarsely using satellite-derived methods, but those maps provide only a general picture. High-resolution mapping is another matter. As of June 2025, only 27.3% of the global seafloor had been mapped to modern standards using high-resolution multi-beam sonar. And multi-beam mapping itself is time-consuming because survey ships must move slowly and systematically so they do not leave gaps. The ocean is just too large for speed alone to solve this. This leads to a very important distinction that gets lost in casual conversation. Mapped does not mean seen. A high-resolution bathymetric map can tell scientists a great deal about underwater topography, slopes, ridges, canyons, and likely habitats. It can guide where to send vehicles and where to focus further work. But a map is still not the same thing as direct visual observation. NOAA's summary makes this point very plainly. Explorers have seen less than 0.001% of the deep ocean seafloor, roughly the size of Rhode Island. Ocean Discovery League reports the same figure and notes that more than 99.999% of the deep seafloor has never been directly observed. So when people say we know little about the ocean, they are not saying no one has made maps. They are saying most of the deep seafloor has never actually been looked at in person, or by camera in any representative way. That distinction matters because a contour map cannot tell you everything that is alive there. How organisms interact, how habitats change over time, or what a place feels like in biological terms. A sonar map may show a seamount, but it cannot by itself tell you which corals are growing on that seamount, which fish use it seasonally, what microbes are active in the sediments, or how the local current regime influences all of that. The same is true for trenches, vent fields, canyon walls, and abyssal plains. The map is the invitation, not the full visit. This is why the ocean can be partly measured and still remain deeply unknown. We may know the broad shape of a place while knowing almost nothing about its living community. It is the underwater equivalent of being handed a topographic map of a forest, and then being expected to explain the birds, insects, fungi, soil and weather without ever stepping under the trees. Another reason the ocean remains unknown is that it changes. This is easy to overlook because people often speak of exploring the ocean as though it were like finishing a museum inventory, where once every cabinet is labelled the job is essentially done. The sea does not behave that way. Water masses shift, species move, sediment settles, storms disturb habitats, vent systems can change, coastlines alter, ice melts or forms, temperature and chemistry vary over time. NOAA even points out that the ocean will never be fully explored because Earth is constantly changing. In other words, even perfect knowledge in one moment would not stay perfect for long. The sea is not a puzzle waiting quietly for the last piece. It is a moving target that changes while you are studying it. The unknown also persists because exploration has been geographically uneven. Ocean Discovery League's recent work points out that visual observation of the deep seafloor has been concentrated heavily in just a few countries and regions. About half of all documented observations have happened within 200 nautical miles of only 3 countries, and 5 countries account for 97% of all deep-sea submergence observations to date. That means our image of the deep ocean has been built from a very small and not necessarily representative sample. It is a bit like trying to understand all forests on Earth after studying only a handful near the same few towns. You would still learn something real, but you would not want to get overconfident at dinner parties. There is a practical reason for this imbalance. Wealthy countries with large oceanographic programs, research fleets and specialized technology can conduct more dives, more surveys and more expeditions. That does not mean other regions are unimportant. Quite the opposite. It means many parts of the ocean remain underobserved because access to the necessary ships, vehicles, sensors, trained personnel and long-term funding is uneven. The sea itself does not care about national budgets, but ocean exploration certainly does. A remote trench or seamount can remain poorly known simply because reaching it regularly requires equipment and money on a scale most institutions do not have lying around between the kettle and the stationary cupboard. Cost, in fact, is one of the least romantic but most decisive parts of the story. Deep ocean exploration sounds thrilling, and sometimes it is. It also involves ships, crew salaries, fuel, maintenance, satellite communications, robotics, sensor packages, data processing, safety systems, launch and recovery equipment, weather forecasting, and often years of planning. The public image is usually a glowing screen and a strange fish. The invoice is rather longer. This is why the deep sea advances in careful increments rather than being fully surveyed in one energetic burst. People do not fail to explore it because it lacks drama. They fail to explore all of it because drama, unfortunately, is not a budget line. And even when data are collected, they still have to be processed, shared, interpreted, archived, and revisited. Exploration is not just travel. It is also data management, and that part is less glamorous but absolutely central. NOAA emphasizes that collecting and sharing deep ocean data are integral to preserving knowledge and making it useful. Seabed 2030 exists in part because a great deal of bathymetric information has historically been scattered among institutions, navies, research groups, and commercial operators. So part of the challenge is not only gathering new data, but also finding, standardizing, and integrating what already exists. The ocean remains unknown not just because some places have never been visited, but because knowledge itself can remain fragmented unless someone does the labor of assembling it. Biology adds another layer of difficulty. The sea is not just one giant habitat. It is many habitats stacked, spread, and mixed together. Coastal shelves, coral reefs, polar waters, open ocean gyres, seamounts, trenches, vent fields, twilight zones, abyssal plains, and deep canyons all support different communities under different conditions. NOAA notes that there may be between 700,000 and 1 million ocean species, mostly animals, and not even counting the millions of microorganisms, and that roughly 2/3, possibly more, have yet to be discovered or officially described. That means the unknown is not only geographic, it is taxonomic. The ocean keeps secrets partly because many of the living things in it have not been formally introduced to us yet. And there is a very sensible reason for that too. Many marine organisms are small, fragile, patchily distributed, deep living, seasonal, or easy to miss. Some are encountered only by chance. Some are known from a single specimen for years. Others turn out to be multiple species once genetics catches up with what the eye had grouped together. Deep-sea species in particular can be difficult to collect without damaging them, because bringing them to the surface changes pressure and temperature conditions dramatically. In other words, even when we find life in the deep ocean, understanding what exactly we have found can take time. The sea is not only hard to reach, it is hard to interpret. There is also a simple issue of scale that no amount of optimism can talk its way around. More than 90% of the ocean is classified as deep ocean, meaning deeper than 200 meters. That alone tells you why shallow coastal familiarity is such a poor guide to total understanding. Humans know coasts much better than the rest of the sea because coasts are relatively accessible. They are where ports, shore stations, routine diving, and repeated observation are easiest. Once you move beyond that into the deep ocean, you're in the majority environment of the sea but the minority environment of direct human experience. This mismatch is one of the main reasons the ocean remains partly unknown. We know the edges much better than the whole. It also helps to compare the ocean with space, though carefully. People often say we know more about the moon or Mars than about the seafloor, and while comparisons like that can get simplified, there is a practical truth inside them. Space is difficult, certainly, but it has some advantages for mapping. Light travels well there. Orbital imaging covers large areas. The deep sea, by contrast, is under kilometres of moving salt water that block light, crush equipment, and force mapping to rely heavily on acoustics and slow survey methods. The ocean floor is hidden beneath the very substance we're trying to move through. It is as if every mountain on Earth wore a thick, mobile, pressurized coat that resented your electronics. Under those circumstances, mystery begins to look less like failure and more like a reasonable outcome. Weather is another quiet accomplice. Even the best ship, crew, and science plans still operate under the authority of the sea and sky. Storms delay work. Swell can make launch and recovery of vehicles dangerous. Ice limits access in polar regions. Seasonal windows narrow opportunities. Long voyages burn time simply reaching target areas. On land, a bad weather day may spoil the picnic and encourage meaningful complaints. At sea, bad weather can consume precious expedition time that cost a small fortune to assemble in the first place. So unknown areas do not stay unknown only because no one has chosen to study them. Sometimes they stay unknown because the window to study them safely was short and the ocean had other ideas. There is, however, a more hopeful side to all this. The ocean is not unknown because it is impossible to study. It is unknown because studying it well requires time, collaboration, money, technology, and persistence on a very large scale. Progress is real. Seabed 2030 has steadily increased the fraction of seafloor mapped to modern standards. NOAA and other institutions continue to expand mapping and exploration. Ocean Discovery League and partner groups are now building more systematic approaches to deep visual exploration so that future observations are more representative rather than clustered in the same few places. The picture is improving. It is just improving more slowly than our impatient species would prefer, which is hardly a problem unique to oceanography. In a way, that slowness is part of what keeps the ocean honest in the imagination. We live in a time when it is easy to assume everything important has already been scanned, indexed, catalogued, and turned into an app with a mild subscription problem. The sea resists that story. It reminds us that a connected ocean covering most of the planet can still contain large areas we have barely seen, habitats we do not fully understand, and species we have not named yet. It reminds us that modern technology, for all its brilliance, still moves one survey line, one dive, one sample, one expedition at a time when faced with enough depth and enough water. And that may be one of the most important things to understand about the ocean's unknowns. They are not just blank spaces waiting for triumphal music. They are signs of proportion. They tell us that the sea is still large enough to exceed our current reach, still dynamic enough to outrun complete inventory, and still complex enough that each answer often opens 3 more questions behind it. Which means that by the time we finally stand back from all of this, from shorelines and horizons and depth and hidden ridges and currents and creatures and the long, unfinished work of exploration, the size of the ocean begins to feel like more than a statistic. It starts to feel like a fact about how the world is arranged, and about how small, curious, and wonderfully unfinished our own understanding still is. And maybe that is the real reason the ocean continues to hold us so firmly, even now after all the charts, the satellite images, the sonar maps, the research vessels, the pressure-resistant cameras, the long columns of data, and the careful work of generations of scientists who have spent their lives trying to describe something that refuses to fit neatly into a sentence. It is not just that the ocean is large, it is that it remains large even after explanation. You can learn the percentages, the depths, the volume, the shape of the seafloor, the movement of the currents, the migrations of whales, the fact that most of it is dark, the fact that much of it is still only partly known. And somehow the sea does not shrink under that knowledge. It becomes clearer, yes, more detailed, more honest, but not smaller. That is worth noticing, because many things in life become less impressive once you understand them properly. A trick loses some of its force once you know how it is done. A building seems less mysterious once you have walked through the service corridors and seen the pipes and cables tucked behind the walls. A machine becomes less magical once you know which part keeps jamming and why someone has to hit it with exactly the right amount of annoyance to make it work again. But the ocean does something different. Understanding adds to it. The more you know, the more it seems to contain. You begin with a beach, a few waves, a horizon, salt on the air. Perhaps a gull behaving with more confidence than basic manners justify. It all feels familiar enough. Then the picture widens. The ocean covers most of the Earth's surface. It falls to average depths measured in kilometres. It hides mountain chains longer than anything we walk on land. It holds trenches so deep that Everest could disappear into them. It contains more water than the mind comfortably manages. It carries currents across basins, shapes weather, stores heat, supports migrations, and still leaves room for species we have not named and places we have barely seen. And after all that, the shoreline remains what it always was, a narrow local edge of something much larger. That contrast may be one of the most human parts of the whole story. We meet the world in small ways. A hand in the water, a walk beside the surf, a ferry ride, a holiday on a windy coast where the sky changes its mind every 10 minutes. That is how reality usually arrives, not as totality but as encounter. We do not experience the ocean as a global system first. We experience it as wet sand under our shoes, cold water around our ankles, a line of foam that reaches farther than expected, a horizon that looks close enough to trust and is not. Then, if curiosity keeps going, the local scene opens and the real scale begins to appear behind it. There is something very grounding in that. The sea does not ask to be understood all at once. It simply allows us to notice more if we are willing to stay with it. First the coast, then the map, then the globe, then the depths, then the hidden floor, then the living systems, then the realization that all of this, the numbers and the movement and the mystery and the physical force of it, belongs not to a distant wonder, but to the ordinary structure of our own planet. This is Earth. This is the arrangement. Most of the visible world is ocean, and perhaps that is why the sea so often changes the mood of a person standing beside it. Not because it is magical in some vague sense, but because it quietly adjusts proportion. It puts things back into scale. A week of emails, delays, plans, opinions, traffic, shopping lists, and the strange private importance of whatever has been weighing on your day can feel very large while you're inside it. Then you stand at the shore, look out, and something in the mind loosens. Not because your problems become unreal, they remain real enough, but because the frame has changed. You're standing next to a body of water that covers most of the planet, reaches depths you cannot picture cleanly, and links coasts, climates, and ecosystems on a global scale. The day remains the day. It just stops pretending to be the whole world. This does not mean the ocean is gentle. It is not always gentle. The sea can be dangerous in the most practical ways. Storms gather over it. Waves break hard enough to kill. Currents carry people where they did not mean to go. Coastlines erode. Floods rise. Ships fail. forecasts go wrong. Entire histories of trade, migration, war, exploration and survival have been shaped by the simple fact that the ocean can carry and destroy with equal seriousness. It is important not to turn it into a polite background for reflection, and forget that. Respect belongs here as much as wonder does. Still, respect is part of wonder when the subject is something this large. In fact, one might say that real wonder is just respect that has had time to become thoughtful. The ocean earns that kind of attention, not because it is picturesque, though it often is, not because it looks good on postcards, though it certainly helps that industry along, but because it is one of the main physical facts of the planet and one of the clearest reminders that the Earth is not arranged for our convenience first. That may sound severe, but it need not be. There can be comfort in that arrangement too. Not everything has to centre us in order to matter to us. In some ways, it is reassuring that there are realities larger than our routines. The ocean does not consult our calendars before shifting heat through a current. It does not pause a tide because someone has booked a beach photo shoot. It does not reorganise the seafloor because a human being would prefer a simpler diagram. It goes on being what it is, and there is something calming in the steadiness of that. The sea is not reliable in the sense of always being calm, but it is reliable in the sense of always being itself. And what a self it is, really. A global connected body of salt water covering about 71% of the Earth's surface. An average depth of around 3.7 kilometres, a deepest known point nearly 11 kilometres down, a volume of about 1.332 billion cubic kilometres, the longest mountain range on Earth hidden beneath it. Most of the planet's water held within it, currents moving heat and salt through it, vast regions of darkness below the surface skin we know best, creatures drifting, hunting, migrating, glowing, filtering, feeding, rising, sinking. A world large enough to absorb ships, storms and silence without ever quite looking crowded. Even now, when satellites watch weather systems cross it, and research vessels map its floor and instruments drift through it, sending back data, the ocean remains partly out of reach, not absent, not ignored, just larger than full possession. And perhaps it is better that way. Complete familiarity is not always the highest form of relationship. Sometimes attention matters more than ownership. Sometimes respect matters more than certainty. Sometimes the healthiest thing a person can say about a part of the world is simply that it is there, it is immense, and we are still learning how to know it well. That learning matters now more than ever, because the sea does not exist separately from us. However much it may feel that way from the shore, human beings affect the ocean whether we live beside it or not. Warming temperatures, changing chemistry, plastic pollution, overfishing, noise, habitat loss, runoff from land, all of these reach the sea. A person can stand on a cliff, feel wonderfully small beside the water, and still belong to a species capable of altering that water in measurable ways. Smallness is not innocence. It never was. So if the ocean teaches humility, it should also teach responsibility. A thing can be larger than us, and still vulnerable to what we do. That is another reason the size of the sea matters. Not because large things are impressive, but because large things can carry the effects of change very far. Warm a current, alter a food web, stress a reef, change the chemistry of surface waters, and the consequences do not stay politely in one place. The ocean connects. That is one of its defining traits. It links coasts and climates. It links species and seasons. It links weather over one region with conditions far away. It links local actions with wider outcomes. To understand how big the ocean really is also to understand how large the reach of our relationship with it has become. Yet even with that seriousness in the frame, it is still possible, perhaps even necessary, to return to the personal scale where most of us actually meet the sea. A shore at dusk. A grey morning with wind pushing spray sideways, a boardwalk, a harbour, a cold swim that felt like a questionable idea right until it was over, a ferry deck, a cliff path, a room near the coast where the sound of waves comes faintly through the window at night. These moments remain small compared with the total ocean, but they are not made less valuable by that. If anything, the larger picture deepens them. The water at the edge of your feet belongs to the same body that reaches into deep trenches and circles under storms and carries migrations across the world. The local and the global are touching in that one line of foam. There is a pleasing honesty in that. You do not need to circle the Pacific to have met the sea. You do not need to descend into a trench or map the mid-Atlantic ridge or calculate cubic kilometres before breakfast. Standing at the shore is still a real meeting. It is just not the whole truth. The whole truth is bigger than the meeting, and perhaps that is why the meeting feels the way it does. We respond not only to what we see, but to what we sense behind it. The horizon is visually simple, but the mind knows, somewhere just below language, that it is looking at the edge of something with far more behind it than the eye can hold. So when people say the ocean feels endless, that is not literally true, of course. The sea is finite. It has measurable area and measurable volume. It occupies basins on a planet of known size, but the feeling itself makes sense. For a creature our size, with our senses, our lifespans, our local habits of movement and thought, the ocean exceeds direct comprehension in a way that can feel very close to endlessness. Not infinite in mathematics, but practically overwhelming in experience. Large enough that the distinction matters less to the body than it does to the textbook. And there is something almost friendly in admitting that. Not everything must be brought down to perfect mental size. Some things can remain just beyond full grasp and still be deeply known in another way. You can know the sea through science, through coastlines, through sound, through weather, through memory, through respect, through the recognition that it is one of the dominant structures of life on Earth. You can know that it is finite and still feel, from the shore, that it goes on longer than your instincts can properly track. Both can be true at once. Perhaps that is where we arrive after all of this. Not at a final answer that closes the matter neatly, but at a steadier one. The ocean is not just big, it is planet big. It is wide enough to separate continents and link climates, deep enough to hide mountain ranges and trenches, voluminous enough to hold most of the Earth's water, active enough to move heat, feed storms, shape ecosystems, and carry life across impossible-looking distances. Unknown enough to keep inviting careful work, familiar enough to greet us as waves on a beach, strange enough to remain larger than every easy picture we make of it. And now, after all these measurements and comparisons and long looks into what lies beyond the shoreline, the sea returns in the simplest form again. Water meeting land. The edge where a person can stand and understand almost nothing fully, and yet enough to feel the scale of what is there. That may be all anyone really needs in the end. Not mastery, not ownership, just a proper sense of proportion, and maybe a little gratitude that the world still contains things large enough to stretch the mind without asking it to break. So wherever you are tonight, whether you're near the coast or hundreds of miles inland, whether the nearest ocean is outside your window or only in memory, perhaps hold on to this for a moment before sleep takes over. The planet beneath you is mostly ocean. Most of the visible surface of Earth is water. Most of that water is deep. Most of that depth is dark. Much of that darkness still remains only partly known, and yet every shore, every tide, every gull-haunted harbour, every cold, bright wave rolling over sand belongs to that same connected world of water. If this quiet look at the sea helped you settle a little, if it gave your mind something large and steady to rest against, I would be very grateful if you liked the video, subscribed to Life Beyond Seen, and shared it with someone who might also enjoy a gentle way of ending the day. It helps this little corner of calm find the people who need it, especially those lying awake at night suddenly thinking much harder than expected about underwater mountain ranges, which admittedly is a niche group, but a good one. And now it is probably time to let the ocean be the ocean again, without asking it for one more figure, one more comparison, one more chart to make it fit more neatly inside the mind. It has done enough already. It has shown us that the shoreline is only the beginning, that the horizon is not an end, that the blue on the globe is not background, and that the world is far more water-shaped than our land habits usually admit. So rest easy wherever you are. Somewhere tonight the tide is rising against a quiet coast. Somewhere a current is moving warm water northward. Somewhere beneath black water, on plains and ridges and slopes no human eye has ever seen, the planet is continuing its slow, patient work. And here, in your own small corner of it, the day is easing closed. Sleep well and let the sea keep watch at its proper size.